the beam and the wave, the upper and lower, that cap or what is called that.
Yeah, they're just separate sections, and together they make up the I-beam.
Yeah.
The eye is just the shape of the thing.
Can you draw a diagram?
Yeah, so if your spar, yeah, is made up, it's got top caps, and then your web, and then the bottom caps. And when you look at it, it looks like the letter I.
Yeah.
Yeah, so it'll go off something like that. Yeah.
Yeah.
Has that answered your question?
No. Yes, but this upper and lower, the eye, what loads are they subjected to? That I am asking mainly.
Bending.
Bending loads.
Yeah, so that it depends which way the load's going, but if you look at a beam that's under stress, that is a bending load. So the top part is under compression. Yeah, the lower part is under tension.
Yeah.
And then if it bends that way, it's the opposite way around.
Okay. Okay, then I got it now.
Yeah.
Okay. Yeah.
Okay, no worries.
Thank you.
My pleasure. Anybody else got any questions? No? Oh.
Jim.
Yeah.
Yesterday we studied about the air cleaner purge valve.
Yeah.
Air cleaner and purge valve. So the internal, how it works, is it important to know? Okay, because I know regarding the vanes and all, but the internal mechanism, that's not important.
No.
Okay then.
No, we know it's there, and it takes out the particles, the solid particles. The inertia of them carries them forward. Meanwhile, the air's deflected, so the clean air goes on into the system. The dirty air is released back to atmosphere by using of the purge valve.
Yeah. Okay then.
Anybody else? All right. In that case, what we're going to look at this morning is fire protection. Yeah, and the fire protection systems and fire suppression as well as part of that. Can everybody see the presentation okay?
Yes, Jim.
Yeah.
All okay.
Fantastic.
Yeah.
Right, so fire protection then, part 3, book 2. And fire protection is split down into 2 sort of separate areas. We have fire detection, where we're going to find out that there is a fire, and we're going to have fire suppression, where we're going to put the fire out, hopefully. Yeah. So the different methods and the different areas where we need that fire protection. So in your toilets, yeah, then your galleys, smoke detectors. We talked about temperature indicator yesterday. That was the sort of thing I was on about. Little bits of tape, and the tape changes colour as temperature changes. And what we found with the indicator strip, as we'll discover later, we find that inside your waste receptacles as well. Your fire extinguishers, therefore suppressing fire or extinguishing fire. All right. First things first, and again worth sticking a highlighter through. When we talk about fire zones, a fire zone is a region in the aircraft where a potential risk may exist following a failure or a leakage of any component, piece of equipment or part of the power unit. When it talks about the power unit, we're talking about the engines. Yeah, so within the aircraft, we've got different fire zones, and that fire zone, the region where a potential risk may exist following a failure or a leakage. Yeah, so within the engine area, if we get a fuel pipe leaking, there is obviously a big risk of fire. So the engine area is considered to be a fire zone. So all got that one, fire zone. Yeah, so to help us eliminate or reduce as far as possible the risks, it is a specification requirement, design requirement that the aircraft has some form of fire detection system. The requirements of that system are that the fire detection system must be capable of providing rapid detection of localized fire or overheat conditions. Yeah, so you've got to have a detection system that will detect small areas of fire, small areas of overheat. And we need to warn the crew about that. So the detection system must have a warning by means of a red light and an audible signal on the flight deck. Yeah, so the system, oh, I've got a little fire here, I've got an overheat here. It'll put on a red warning light and it'll have all the whistles and bells going with it as well. Please note that the detection systems will not automatically operate the main engine extinguishers, but in some installations, yeah, the system may be used to shut down an APU and may operate an APU fire extinguisher automatically. So the main engines, it's got to be the decision of the crew to activate the fire extinguishers. With the APU on some aeroplanes, slightly different because the aircraft is left unattended for long periods. It's just running away on its own. If anything happened, then the system may well shut the APU down and activate the APU fire extinguisher. The system's got to accurately indicate that the fire's been extinguished, and it needs to tell us if the fire's reignited. Yeah, it's all very well telling us we've got a fire, but if that fire crops up again, then the system needs to tell us about that. System's got to be durable. Just let your man in here. It's got to be durable and resistant to damage from oil, water, and other fluids that may be present in the area where it's installed, which makes sense. We need this thing to be operable. It needs to be able to detect fire, so we don't want it being adversely affected by any fluids. It says oil and water. Oil, a famous one. You know, if you're in an engine bay or a hydraulic compartment or whatever, lots of potential for leaks there. So we don't want that oil inhibiting the operation of the system. Yeah, system's got to include an accurate and effective method of testing so that both the flight crew and us, the engineer, can check the integrity of the system. What we need to do is just to be able to carry out a test where we press a button, the system will tell us whether it's serviceable or not. And certainly prior to flight, that confidence check, that test of the system, we need that confidence that if anything goes wrong, the system's going to be ready to work. Yeah, system easily inspected, easily removed and installed. Yeah, we don't want any complications with it. System and its components designed so that the possibility of false indication is unlikely. Nothing worse than your fire alarm going off and it's absolutely nothing. Yeah, it's just a false warning. And the problem with false warnings is we get used to them and we ignore them. We ignore the warning after a while. And you can guarantee, absolutely guarantee, that the one time that you ignore that warning, it will be the real thing. System's got to require a minimum of electric power and must operate from the aircraft electrical system without the use of inverters or other special equipment. Again, that one is worth sticking a highlighter through. the fact that the fire system, we don't want any complications with it. It needs to be simple. Yeah, tapped off the aircraft electrical system, no inverters, no niff-naff like that. So chances are it's going to be a DC type system. Yeah, we don't need any anything special for that. So we just podge the button and it's going to work. And the detection side of it going to work automatically. The main engine or the main power plant fire detection system should contain an audible warning to supplement the visual indications. Well, that applies to all the fire warnings. It's just the engines tend to be the usual suspects when it comes to fire. That audible warning may be isolated during critical flight conditions, yeah, but if a manual cancelling facility is provided, it should reset automatically when the warnings cease. What that's saying is that we've got to have the lights, the red lights, telling us we've got a problem, and we've got to have the audible, the noise, the bells, the whoop, 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 to tell us that we've got a fire. But as the pilot is concentrating on working out what's going on in that, those bells can be a distraction. So we've got the facility there to mute the bells, yeah, cancel the bells. But that audible warning has got to reset. So if the fire reignites for whatever reason 10 minutes down the line, then the audible warning's got to activate again as well. Yeah. So power plant, visual indications, pardon me, manual cancelling, but it's got to reset. Yeah. The master caution light and the fire caution or fire warning light. The master caution tends to be amber. The fire warning, remember that your fire warning is a red light. Yeah, we're in a whole world of pain if we've got a fire, so you get a red light for that one. Right, so our setup then, yeah, depending on the aircraft, depending on the fire zone and the risk associated with it, we're going to have fire detection and smoke detectors at various locations throughout the aeroplane. Yeah, the engine and the APU areas will have a detection system. They'll have a warning that's going to tell us that we've got a problem there. And a suppression system. When it talks about suppression, we're talking about extinguishers. Yeah, so the engines will detect a fire. They'll give us the warnings, and we've got the extinguishers there. It says about the APU. The APU, an external warning as well, because the aircraft is left with the APU running, but it's unintended. We're going to have an external warning. Yeah, so if the fire system goes, there'll be a horn sounds adjacent to the aeroplane, and everybody knows that aircraft's got a problem. It's a bit like our equipment cooling. Yeah, we said that there was a warning horn for that. So if you get a failure in the cooling system for your avionics, there's a warning horn normally in the nose wheel well. It's the same with the APU. There's an external warning horn if fire's detected or an overheat's detected. The equipment bays on the aircraft, avionic bays, that sort of thing. Cargo compartments, baggage compartments, they're going to have a fire detection system. And again, there's going to be a warning system, the red lights and the bells on in the cabin. Not every aircraft, but a lot of aircraft will have a fire detection and warning system in the wheel wells. The reason for that came from, I think it was a Nigerian aircraft, and it was carrying pilgrims back from Mecca. What had happened, the aircraft had had a long taxi, the wheels heated up, and as the aircraft took off, the undercarriage retracted. Because the wheel well was sealed, there was no cooling over the hot wheels. Because it was a sealed area, the heat increased, pressure increased, tyre burst. The tyre obviously containing air, air contains oxygen. So then within the wheel well, a fire started, and the crew had no indication at all that they had a problem there until the fire had burnt through into the main cabin area. So nowadays, all modern aircraft, we've got a warning and detection system within the wheelbase. And as we mentioned yesterday, if we get a leak in a hot air region, that hot air can be really, really dangerous. It can melt wires, it can damage structure, all the rest of it. So a lot of aircraft now around the hot air ducting and following the hot air ducts, there are detection detection methods, I'll say. There are different types of detector that we'll look at in a bit, but there's a detection and a warning for the areas around hot air ducts. All okay with that? Those are the requirements of our fire detection system. It needs to be simple. We need the confidence that it's going to work. And the various locations we're going to put it. Make sure you've highlighted what a fire zone is. Make sure you've highlighted the fact that it's going to be a visual and an audible warning if there's a fire, and that visual warning is a red light. Okay with that? Bingo. Yeah. I just put that up there because it's a nice picture, but yeah, it gives us an idea. Power plant, overheat, fire, whatever it might be. The warning system is going to activate a red light in the cabin, all the bells going off, and now it is a conscious decision of the crew as to whether they want to activate the extinguishers or not. They've got to assess the situation and decide what's best. Okay, so we've got various types of fire detector that we're going to dot around the aircraft, and the type of detector that we use depends what area it's going to be used in. We have thermal switches. Yeah, we'll have a look at those. Continuous wire. A continuous wire will cover a large area, better known as fire wire. Yeah. We have the sensor responder, which is a type of fire wire but operates in a different manner. Then we've got infrared flame detectors, smoke detectors, all of which are going to give us some sort of indication that we've got a problem in the aeroplane. Boom. Yeah, so your thermal switches then, are often called spot detectors. Yeah, there are different types of thermal switch. Sorry, I'm thinking ahead of myself here. We can dot them about the aeroplane, different positions. Yeah. So thermal switch, there are different types. The one that's on the slide is a sliding piston. Yeah. And what happens with the sliding piston? It's held in a little cylinder, and within there there's two metal wires, and on the wires there's a set of contacts. Yeah, as the switch heats up, this little piston starts to expand. So as it expands within the body of the detector, it starts to move, and as it moves, it'll bring a set of contacts together. Yeah, and those set of contacts, once they're made, will put on the fire warning. Circuit diagram for it, and as I said the other day, I do not profess to be an electrician, but with all our circuits, to ensure safety, they're wired in so things are duplicated. In this case, we've got a loop B and a loop A, and the detectors are wired in, I'm pretty sure it's in parallel. Yeah, I'll just have a look in my notes just to make sure I'm not lying. But the way the detectors are wired in, it makes sure that if there's a problem with one, that the extinguisher will still operate, or the warning, sorry, will still operate. Yeah, detectors, these detectors may be used separately or maybe used together in a combined fire and overheat system. Smoke detectors we'll talk about in a minute. Spot detectors, thermal detectors. Circuit in which one or more thermal switches are connected into an electrical circuit. Yeah, if one or more thermal switches in the circuit, they are connected in parallel. Please put your highlighter through that one. Yeah. So if one switch closes, a warning is given. Yeah, if there's any problem, a short circuit in any of the loops, then the other one is going to make sure that we still get that warning. And as it says there, for the thing not to operate, you've got to have two faults in condition. Yeah, a double fault must exist before a false warning can occur. Yeah, as we said within, yeah.
So this in parallel, this is spot detector, right?
It's spot detector, yeah.
Parallel.
The thermal switch in parallel.
Thermal switch in parallel.
Yes, it's
like switch or detectors. I think individual detectors are in parallel.
If there is more than one used, it's in parallel. Yeah. Just give me 2 ticks.
Controlled by single switch and detectors are parallel, right?
No, it's automatic. Yeah, the spot detector. Right, the set of notes I've got on page 8. Yeah. Whereabouts it? Page 8, where it says thermal switch fire detection system. Yeah. Ching, ching, ching. If more than one thermal switch is in the circuit, the switches are connected in parallel. Yeah, and the way the switch works, as you can see on the slide, yeah, you've got your 3 switches, and you've got 2 separate activation loops. Yeah, so if you get a failure or a short circuit in one loop, the second loop will still be monitoring. So if there's a fire or an overheat, this thing will still activate. The way it activates is if you get an overheat, that's meant to be a fire or an overheat situation. Yeah, the detector will detect that. This little sliding piston in the cylinder of the detector, as the temperature increases, that sliding piston is going to start moving. It's going to start sliding along inside the cylinder, and as it does, it's going to cause these 2 contacts to come together or separate, whichever way the thing's set up. Yeah, and as those contacts either make or the break, yeah, it's going to send a warning signal to the cabin. You okay with that?
Yes, Jim.
Yeah, so it's an automatic thing. Once those have put on a warning sign, warning light in the cabin, then it's going to be up to the pilot to take any action that he deems fit. Yeah, so it's entirely up to him how he wants to play it from there on in. Yeah, so that's your thermal switch. Yeah, the sliding piston type switch. And as I said, just from the notes, the contacts on a spring bow located within a steel barrel. Sufficient temperature rise, the outer steel case expands, removes the compressive force on the spring bow, and allows the contacts to close to complete the circuit. Yeah. Not a lot else to remember on that particular page. Just the fact that all these spot detectors look the same. So if we need to replace a spot detector, the only way we're going to make sure we've got the right one is by part number. Differential expansion switch is again another type of point detector. Again, that's just reiterating that the things are connected in parallel, and you should have highlighted that. The differential expansion switch just works on the principle. Sorry?
Please back to the that back slide once. Okay. This one and this thermal fire switch fire detection same. This if more than one thermal switch is in this. This is different. Differential expansion and this is different, no?
Only in the way that they operate. They're still going to fulfill the same function. Yeah, it's just this one, as the temperature increases, yeah, it'll expand. As it expands, as it says on page 8 there, as the thermal switch, it's got the little sliding piston inside it. So as temperature rises, yeah, the outer case expands, so that the compressive force that's on the contacts, yeah, where's my bloody thing gone? So as that outer case expands, it relieves the pressure on here, and that allows the contacts to make. Once the contacts are made, that's what's going to put the warning sign on, or the warning light on. Yeah. You with me there? Yeah. That's your one type of spot detector. That was the thermal switch. Yeah, the differential expansion switch. Again, it's a spot detector, but it works on the principle of the different expansion coefficients of different metals. Yeah, so what we do with this, we put two metal strips in with the contacts on them, but the metal strips are made of different material. Yeah, so they're going to expand at different rates. As the detector warms up, yeah, one of the strips has got insulation on it. Yeah, things warm up. Yeah, the two metals are going to start expanding, but they're going to start moving at a similar rate. Yeah, as temperature increases and increases, yeah, the lower half is going to strike a stop. Yeah, and as the the slower moving material, as that hits the stop, the faster moving material is going to carry on, and that will break the contacts. And again, that's going to put the warning light on the in the cabin. So your slow build up, yeah. Rapid temperature rise, yeah. The bare strip, the one without the insulation on, is going to receive more heat, and that's going to expand a lot quicker. And as it expands quicker, it's going to break the contacts. So even if we've got a slow overheat rise or a very fast rise in temperature, those contacts separate, and that's going to put the warning light on in the cabin. Yeah. So slow temperature rise. These are two different metals. They expand at different rates. A slow temperature rise, they'll both move pretty well together. The contacts will remain in contact. As soon as we hit the stop, the quicker moving metal will separate, break the contacts, warning light goes on. If you get a rapid rise in temperature, because the lower strip has got the insulation on it, the upper strip is going to feel that heat. It's going to expand a lot quicker than the lower one. And again, that's going to break the contacts. And away we go. These things, what else do I need to say from them? They're set for different temperatures. So as we said before, we've got to make sure that we get the right spot detector for the right temperature for the right area. And the only way we're going to do that is via our part number. That's what your expansion switches look like. Your thermal switches are just little metal barrels. Yeah, just little metal barrels. That's all you see. Your thermal switches tend to look like that.
Jim.
Yeah.
Like in the previous spot detector, previous slide.
That one?
Yeah. Yes, Jim. In this switch, so what happens when this the maybe a fault rate also come, right, once it gets sorted out?
Say that again, sorry.
When this switch, like this thermal switch,
yeah,
these two wires connected parallel to each other, there is a chance of being sorted out, right? Of fault indication.
That is why they are wired in parallel. So you got loop A and loop B. So if you get a fault in loop A, yeah, loop B is still going to give you your indication. If you get a fault in loop B, loop A is still going to give you your indication. Yeah, that's what your loop A and your loop B about, and wiring them in parallel means that if you get a fault in one of the loops, you're still going to get your indication. Within the switch, all you've got is a steel body or a metal body with that little sliding piston inside it. As you get a temperature rise, the body is going to start to expand, yeah. And as that body expands, it's going to allow the contacts to make, and the contacts making are going to put the warning on in the cabin. Yeah, so you can see you've got your loop B there and your loop A here. If you get a fault in loop B, those contacts will still make. Loop A will still give you your warning. And likewise, if you get a fault in loop A, loop B, the contacts are still going to make. Loop B will give you your warning. Okay.
So loop A and loop B are in back of working.
No, they're both together. They're both working together. It's just if you get a fault in one of them, what you don't want, what we said right at the beginning is we don't want a false fire indication. So the purpose of having A and B wired in parallel is that if you get a fault in one of them, yeah, let's say we get a break in loop A for whatever reason, yeah, loop B is still operating. It's still going to give you a warning. If that detector operates, if you get an overheat, the contacts make, yeah, loop A is still going, loop B is still going to put on the warning light. Yeah, this thing is reacting to heat. Yeah, so you've got your loop B, which is that wire there. Your loop A is that wire there. So it doesn't matter which one's working or which one's unserviceable. If those contacts make, then the warning light is going to be illuminated and the bell's going off.
That means both contact is necessary to give the warning, right?
The contact points, yeah, that's making your circuit.
Okay.
Yeah.
Okay.
You sure?
Thank you, Jimmy. Yes.
Anybody else? Deathly silence. Okay. Right. So those were our spot detectors. They're just the two different types of spot detector, and hopefully we've highlighted the fact that they're fitted in parallel. If there's more than one of them in the system, they're fitted in parallel. So if we get a failure in one, then the other is still going to give us our warning. Your continuous loop fire extinguishers are what we conventionally know as firewire. Yeah, your firewire is great because we can stretch it around over large areas. Yeah, we can run it around engine bays, undercarriage bays, along the sides of our hot air ducting. Yeah, so it's a continuous loop. It starts at a control box, it'll run around the circuit, and it will end back up at that control box. There are two types. Yeah, there's a resistance type and a capacitance type, and no matter which one you're using, yeah, what's happening is as heat is detected, yeah, the capacitance or the resistance of the dielectric material in the wire is altered, and that allows a current to flow. Current flows is recognized by the control box, the control unit, and that is what's going to again set our warning system off. With our continuous loop, yeah, as it says on the slide there, dual loops are used to avoid false indications. Yeah, so they're going to be duplicated. As with everything, duplication, yeah. So we can run from our control box. Yeah, we can run the firewire out through the various different areas to where we need to be. There are two types of element that we talk about. There is the fen wall and the kiddie. Yeah, the only difference between them, the operating principle is the same. We've got a center core on the fen wall, and between the center core and the outer tube, there is a dielectric material. With the kiddie, yeah, there are two elements. So if you think kiddie, two Ds, kiddie, two center elements. With the fen wall, the outer element, the outer casing is the earth. With the fen wall, yeah, we've got a conductor and an earth, and that earth is soldered to the tube at some point further down. Yeah. The dielectric, it's some sort of salts in that make up the dielectric, but we don't need to worry about that. What we do need to know, though, is that there is an electric current, a very small current running through the dielectric material. As we get a rise in temperature, the resistance of that dielectric decreases, and it allows the current to flow between the conductor and the tube. Yeah, so that's making a circuit, and by making a circuit, that's going to put the warning light on via the control box. With the kiddie, exactly the same sort of thing. We've got the dielectric. As temperature rises, the resistance in the dielectric reduces, and that allows the current to flow between the conductor and the earth. And again, that's completing the circuit, and that's going to put the fire warning on. We want the system to reset. So again, as temperature decreases, the resistance is going to increase, and that's going to stop the current flow between the two, and that will cancel our warning. So again, yeah, dielectric material, yeah, resistance changes, current flows. As the current flows, sets the alarm off. Fenwall one, because you're using the sheet, resistance changes, and again we'll get fire warning on. Okay with that? Any problems?
Jim?
Yeah.
The dielectric negative resistance coefficient, right? This material that increases as resistance also increases in normal conductor, because it's in reverse fashion, so it could be a negative resistance in the dielectric.
As the temperature increases, the resistance of the filling material decreases as an inverse coefficient of resistance. Yeah, fine. Like I say, I'm not an electrician. I just know that as the resistance changes, the resistance is going to decrease to allow the current to flow. So the inverse coefficients mean nothing to me. It's just words in the book.
Okay.
Yeah. But yeah, that's what it says. Inverse coefficient of resistance. Yeah, I'll take its word for it.
In a book, Jim?
Yes, it's in the book on page 11.
Okay, Jim. Thank you.
All right.
Yeah.
Yeah, the current path always through the filling material, the dielectric, and that governs the strength of the current flow in the controller. With that arrangement, it says the warning is not compromised should a break occur in the loop. Yeah, so even if you get a break in the loop, it's the filling material that has the current running through it. So again, the current's going to change the resistance. Anywhere where there's an overheat, it's still going to operate. There's a test facility in there, so we can check the system before we go flying and have confidence that it's going to work. Yeah, the kiddie type, as we talked about, yeah, has got the dual core. So if you remember the double D for the twin elements, just a way of remembering it. Sensing elements are in duplicated, so there's two loops, yeah, and they run around the circuit together. Each circuit got its own control unit, so although they're running together, the control units are separate. So again, it's still going to pick up if there's a problem. Page 13, yeah, and on there, the sensing elements are held in place by dual clamps riveted to the tube assembly approximately every 15 centimeters or 6 inches. Yeah, so as the loops go around, yeah, the support clamps for the two loops, yeah, are held together by clamps. And those clamps are round about 6 inches apart. Little rubber grommets in there. to protect. Okay with that? Any problems there? And again, just another example. Yeah, showing your detector. You've got that resistive core in, electrical current through the dielectric, rise in temperature, dielectric resistance decreases. That current can now flow between the conductor and the earth, and that makes the circuit, and that's what's going to put our warning light on via the control box. The other type of firewire we get is the capacitance type. That type of firewire constructed in the same way, routed around the particular areas in the same way, but the controller is senses the capacitance. Yeah, capacitance increases with increased temperature. Central electrode fed with half-wave AC. Stores it, returns it. Stored charge increases with temperature. When you get a warning, the warning level, yeah, that warning temperature is reached. That back current will operate the control box. Yeah, so the capacitance type and the resistive type. Yeah, your resistive one then, 2 independent loops of firewire supported by a central structure, a rigid tube. Both loops have to be activated for a fire to be reported. The resistive one, we've been through that. Central electrode surrounded by a filler inside the capillary tube. Capillary tube is the earth to the structure. 2 ends of the wire are brought together at a junction at the control box. I'm not going to go into Wheatstone bridges and all that shit. We don't need to. System runs on 28-volt DC. Yeah. Increase in temperature, resistance increases. Leakage. Yeah. Wheatstone bridges, forget about those. We just know that it's going to send a warning to the controller, and that's going to put the warning light on in the cabin. If that firewire is damaged, if it's crushed, a false warning can be generated if the damage is severe enough. Hopefully that's never going to happen. Yeah, I'm not going to worry about that, and I wouldn't expect you to either. It's just how that's your Wheatstone bridge. It's just how the firewire is sending its signals through. The capacitance unit, the central electrode connected to a charging and measuring unit. That charges the central electrode for a set length of time. Discharges the signal into the measuring unit. Measuring unit measures the capacitance, compares it with a reference. Increase in temperature, capacitance increases. Measuring unit senses that and will send out a warning signal. If with the capacitance the firewire is crushed, no loss of capacitance, no false indications. Yeah, so your firewire capacitance or resistance types. Yeah, and again, wound round large areas. Yeah, back to the control box. Where fire, if there is a fire indicated, it will set off the warning. Nothing to worry about there. We've seen that lot, seen that lot, seen that lot. Talks about the fire indications, the next bit, yeah. If we get a fire warning, yeah, we're going to get the indication. Overheat, amber lights, fire indication, red lights, yes, don't need any of that. Yeah, the bell cut out, don't forget about that. You can cancel the bell, but it's got to reset.
Jim.
Yeah, hang on, I'm just looking to make sure that there's nothing that we need to worry about.
Okay.
In the test. Yeah. No, we're all fine there. Right. Yes. Question.
Jim, do we have to note this grommet thickness? Approximately 15 centimeter grommet are provided to cushion the sensor tubing in the clamps.
Yes. What it's saying is that these supports, yeah, you've got a support tube, and that support tube is supporting the firewire elements, loop A, loop B.
Yeah.
Those support clamps are round about 6 inches apart. Yeah. When it's talking about the grommets, we're just looking at those little rubber inserts, and they're just there as a protection from to stop the clamp chafing through the firewire.
Okay.
Yeah, so that's 6 inches apart for the supports. Yes, I have seen that one before.
Have to highlight this?
Yes, I did say that earlier.
Okay.
Yeah, stick a highlighter through that.
Thank you.
Right, typical warning panel that shows us in the notes. I think this is a 737. Overheat detector, fire detector. We've got the test switch. Yeah, the fire bottle handles. Yeah, where we can make our selection. The bell cutout, so we can silence the bells. Yeah, and then we've got the fire handle for the APU as well. So your overheat detector, the A loop, the B loop must sense an overheat or a fire condition. Yeah, so we've got normal where both are working, and then we've got the overheat or fire warning. Yeah, the fire bell cutout silences it down. Extinguishers, we're going to look at those later. There's a test switch for them. Yeah, and there's indicators to tell us what condition the fire bottles are in. Again, indicators to tell us whether the bottles have been discharged or not. Yeah, overheat detection, whether it's in the normal condition or whether we're looking at fire detection. Warning lights for engine overheat. Test switch, yeah, APU fire warning, and the engine fire warning. Yeah, and again, just another example with the lights on. Yeah, if you've got a fault in the system, we're going to get the indication. Fire bottle discharge, yeah. Fire bottles, what condition they're in. In this case, it's saying they're discharged. Overheat warnings, and that well there is the wheel well. Illuminated, yeah, extinguisher test. You press that, and that's going to tell us that the extinguishers are okay. Yeah, fault detector light. So if we've got fault in the circuit, APU fault, bottle discharge. Yeah, we'll cover that in a bit. So once we've activated the fire bottle, we need to know that it's empty. So we'll get a light telling us. The wheel well, we've just mentioned that. And the engine overheat lights. If we get overheat associated with the engines. Your warnings, yeah, the master caution light is an amber light, yeah, and it'll tell us that we've got a problem in a system. The fire warning light is a red light, yeah, and that tells us that we've got our fire. The fire warning accompanied by the audible warning. Yeah, so with the fire warning, we're always going to get the bells. Digital firewire, yeah, is the best of all worlds. The digital firewire is a mixture of your capacitance and your resistance system. Yeah, and the beauty of the digital firewire, it's all sealed at manufacturer, so we don't need to worry about getting moisture or anything, contamination in there. We don't need to do any servicing or maintenance on it. It is pretty much a fit and forget system. Digital firewire, absolutely broad, widely used, reliable, accurate, just about identical, apart from the fact it's all sealed, totally environmental sealed, fit and forget. Something in there I need to mention to you about the digital systems. That's it. Bottom of page 22. With the digital system, the control unit applies a square wave reference signal to the detector loop. So in the event of a fire and overheat, the rise in temperature will cause the shape of that waveform to change. And the digital controller will pick up the fact that the reference signal, the square wave has changed shape. And again, it's all set up internally. And once that square wave has changed shape sufficiently, it'll set off the warning. Single dual loop configurations continue to function even if the element is severed, because they're powered from both ends. So it doesn't matter if you get a break in the system, it's still going to indicate a fire. But if you please remember that the digital firewire sends out a square wave signal. Let's just go back. That's the digital. Yeah, so your control box sending out this square wave signal. Yeah, and if we get a fire, yeah, that square wave is going to start to change shape. And as it changes shape, the controller is going to see that it's changed shape, and it's going to send out the warning light. It's sending out power from this end and power from this end. So even if I have a break in the circuit, sorry, that rubber doesn't work, but if I've got a break in the circuit, I'm still going to get my fire indication. Okay with that? Yeah, those are the little grommets. Only thing to remember about the grommets, they've got a little split in them. That little split goes to the outside of any radius in the firewire. So if we've got to put a bend in, yeah, we've got bend radii that we've got to comply with, but the grommet, the outer, the split in the grommet goes to the outside of any radius. Another fire detection system. I'll just do this one, then we'll have a cup of tea. Other fire system detection we get is the continuous length fire detection system, sometimes known as the Cistern-Donner. Yeah, the Cistern-Donner continuous length. Again, it comes uses a 28-volt supply from the battery bus bar. Again, we're not putting any complexity into it. And the way that works is we have a continuous length unit, and within the I'll call it, what should I call it? Within the element, yeah, the firewire element, there are two gases. There's an averaging gas called helium, and the center portion of the tube is filled with hydrogen. Yeah, so you've got two different gases. The hydrogen is held in, retained by a special titanium wire. Yeah, that titanium wire keeps the gas in, but it also will allow it to eke out in the event of a temperature rise. So the cistern donor system has a control box it's attached to, and the wire goes off, and the hydrogen and the helium and everything is sweet. Within the control box, we've got what they call the integrity switch, and that is there to make sure that the system is serviceable. Yeah. Then we have an overheat switch and a fire switch, an alarm switch. Yeah. If there's a fault in the system, if somebody with a size 10 boot or somebody knocks it and we get a leak, the helium is going to leak out. As the helium leaks out, we're going to get a drop in pressure, and that drop in pressure is going to cause the integrity switch to open. Because the integrity switch is open, that's going to send off a fault signal to the control panel. Okay with that? If we get an overheat, let's say we're running this alongside hot air ducting, yeah, and the hot air ducting is leaking, we're going to start to get a temperature rise. As we get a rise in temperature, that hydrogen there is going to increase in pressure, and that hydrogen is going to start expanding. Expanding increases the pressure. As the increase in pressure occurs, that helium is going to start leaking out of the center core. As that helium ekes out, it's going to increase the pressure even more, and by increasing the pressure, it's going to cause the overheat switch to activate. And again, that's going to put on your overheat warning light in the cabin. With our fire, yeah, we're going to get a rapid rise in temperature if we've got a fire. That rapid rise in temperature, the helium and the hydrogen are going to expand very rapidly, increase pressure very rapidly, and as they increase that pressure, again, they're going to set off the warning light in the cabin. Yeah, so what do we need from note on that? Yeah, sensor works on the gas flows. Yeah, helium gas in the tube exerts a pressure proportional to the average temperature along the entire length. Yeah. If the average temperature exceeds a specified level, the helium pressure will close one of the two pneumatic diaphragms, indicate an overheat. Fire occurs. Yeah, the center wire will now release a large quantity of hydrogen, and that will increase the total gas pressure, and that will close the second switch and put on the fire alarm. Yeah, when the fire is extinguished or when the overheat temperature reduces, the center core is able to reabsorb that hydrogen. So as it reabsorbs that hydrogen, the pressure is going to drop. As the pressure drops, the switches are going to reset. Yeah, and again, just what the thing is, your control unit, yeah, your alarm switch, your integrity switch in there. The tube holding the gases and the center bit, the hydrogen core material, the helium, what they call the averaging gas. So long as everything's happy, yeah, the pressures nothing's going to happen. Get a rise in temperature, that helium's going to expand. Yeah, that rising gas pressure is going to set off the alarm. If we get a fire, the hydrogen is going to be released from the center tube. That combined with the helium gas is going to put a great wallop of pressure in, which is going to set off the fire alarm. Yeah, it says it's got this protective wrapping around it just to give it that extra protection if anybody stands on it or anything. Again, just examples of your firewire, your fen wall with a single conductor, the dielectric material, your kiddie, the two elements surrounded by the dielectric, and the cistern donner is the pneumatic type with the hydrogen and the helium all encased in a stainless steel tube. Just looking through there, don't worry about the temperatures. Yeah, just if there's a high temperature over a small area, rapid response from the unit. High temperature over a longer area, we're going to get the overheat warning, and then a lower temperature over the total length, a larger length. Again, we'll get a warning there. Can't see anything else. Again, the detectors installed in pairs, loop A, loop B, held in place, stainless steel supports. All right. I think what we'll do, we'll have a cup of tea before we go on to the infrared. Has anybody got any questions on any of that little lot? No. Right, I'm at that 10:27 now, according to my computer. So we'll call it 10:30, so 10:50 my time. 20-minute tea break. Yeah, well, it's actually 23 minutes according to my clock, but we'll call it 20 minutes. So go and stretch your legs, grab a cuppa, and we'll regroup in 20 minutes if nobody's got any questions.
Okay, sir. Go ahead.
Okay.
Okay, sir.
You've got a question?
Jim,
No, sir.
can you explain one integrity switch, this one? What's the function of this?
It's the integrity switch is just to make sure that everything is working properly. Yeah, it's making sure that there's no leaks in the system, that gas is there and at the correct pressure. If we get a leak in the system, yeah, you're going to get a pressure drop. That integrity switch will break, and that will put on a warning light in the cabin.
Okay, thank you, Jim.
There you go. So everything fat, dumb, and happy. The integrity switch is made. If you get a leak, yeah, pressure drops, that switch breaks, and that's going to give us a warning light to say that there's a fault in the system.
Okay.
We'll get a fault light.
Okay, thank you.
Okay.
Okay.
Anybody else? Right, we'll go and have a cup of tea then. I'll see you in 20 minutes.
Okay, Jim. See you.
Aye. All right, chaps. So got everybody back. Looking good on my screen.
Yes, sir.
Excellent. Thank you very much. Yadav, you have your hand up. Is that a question or a typo?
Is that I am in the class.
Ah, right. See, sensible man. Thank you. Right, before I plod on then, anybody got any questions on anything that we covered before break? No? Right. We'll go on then to infrared fire detection. Infrared fire detection, what happens is we put infrared sensors, fire detectors, into the required areas. And those infrared sensors are monitoring the light that they're picking up. And that light is made up of radiation, different types of radiation. So what happens from the infrared sensor, that radiation falls on a window in the sensor, and then that radiation gets transmitted to a filter. And the filter is set up and it gets rid of everything outside of a certain wavelength. Yeah. Anything in that wavelength has been analysed and is found to be the radiation that we're giving off is a fire. So a very, very small waveband of radiation. Yeah, if the detector picks up anything within that wavelength, it'll put on a fire warning. Is the very, very basic outline of the infrared detector. Flame detector, yeah, sits in the fire zone, in the potential fire area, and it monitors the light coming on. That light giving off radiation, all that radiation falls on the flame detector, and it goes through to an analyzing unit, or I'll call it that because I don't know the right name for it. But the analyzing unit filters out all of the radiation apart from a certain wavelength. If it picks up radiation within that wavelength, it knows it's a fire, and it'll put on the warning light in the cabin for us. Very, very simple by all accounts, but for me, very, very clever in its own magic. Yeah, to make sure that the brains of the outfit's protected, yeah. Part of the flame detector is inside the fire area, and the rest of the gubbins, the wiring and everything outside the fire area. So there's a firewall between the two. Yeah, and again that'll put on the warning light for us. Is there anything else we need to know there? Not really. Master caution, we've talked about that before. If we get a fault in a system, yeah, the master caution will come on. The fire warning will come on, and it will stay red. The bells, we can punch the button and the bells will cancel. The fire warning will stay on until that fire has been extinguished. Ta-da! Right, your flame detectors. Again, we don't need to go too deep into this. It's just to give you an idea. Yeah, we've got the flame detectors in the engine compartments. Let's say the number 2. Yeah, the supply coming from your DC bus bar. Flame detectors, yeah, and those flame detectors, the signal goes through an amplifier, and depending on the signal, yeah, it'll put on a warning light in the cabin, and then it's up to the crew to decide whether they want to activate the fire extinguishers or not. Yeah, that one's certain helicopters. Yeah, all the same. Basically, all we're doing is looking for fire. If we find a fire, we're going to put the warning light on in the cabin. There's not a hideous amount else to say about that little lot. I don't think there's anything that we need to worry about in the notes. Early days, yeah, the infrared was very, very poor because all we'd have to do is open up a panel, and that changing light would set off the alarms. The new systems, very good. Yeah, the filters, keeping the radiation wave bands very, very tight. And nothing else there. There's a description of that picture that I've just shown you in the notes. Again, don't worry too much about that. Stick a highlighter through the fact that the power supply is 28 volt DC, which I think is the same for pretty much every aspect of the fire systems. Cancelable. Detectors. Posh picture. Test procedures. What I would say with test procedures, I'm just going to look through, make sure that there's nothing jumps out generically. But testing a fire detection system, because it's so critical, it really is a matter of following the AMM. Yeah. The simple test, yeah, pressing a test button and making sure that all the correct lights come on. That's your simple test. Then we go deeper into checking the flame detectors by waving a light across them and getting sure that we get the lights on. But we won't get anything on any of that little lot. It really is a case of the fire detection systems, take the AMM out and follow that step by step, because we don't want anything going wrong. So that was our fire detection and overheat detection. Any questions on that? Because now we're going to have a look at smoke detection. The old story where there's smoke, there's fire. Yeah. So what we're going to do in the aircraft is put smoke detectors in various areas to give us, again, previous warning before we get to overheat points and flash points and all the other good stuff.
Jim?
Yeah.
This infrared is used mostly or not?
They're used on different types of aircraft.
Okay, so the modern Boeing Airbus, they use this infrared or not, that I'm asking, or it's used in smaller aircraft?
The answer is I honestly don't know. I would guess the larger aircraft, but there'll be smaller aircraft out there, more modern smaller aircraft, your Hondas, that sort of thing. They could quite well use them. Yeah.
Okay.
I would say they're probably more common in the larger aircraft, but there will be small aircraft that would make a liar of me.
It has a disadvantage of sunlight, right?
No, that's what it's saying. It used to, but the over the years they've improved that detector no end. So now it doesn't matter if you open a panel and you get sunlight on there. The wavelength that it looks at is so refined, it'll only pick up the radiation given off by a fire.
Okay.
Yeah, in the early days, the radiation bandwidth was so big. If you open the doors, sunlight would set off your fire alarms. But they're very good now, really good.
Jim.
Yeah.
Is this overheat or fire protection system can passes from the different zone, or it is separate for different zone?
Generally, it's separate for different zones because you've got to identify where a fire is. Okay. Yeah, so if you've got a fire in your left-hand engine bay, yeah, you don't want a false indication telling you it's in the right-hand side, so they're normally all separate. You can have a fire detector running through a separate area, so long as it's protected from that area. So let's have a look. Although this is the smoke detector picture, yeah, let's just imagine that that's the fire controller, and the fire controller will have engine 1, engine 2, landing gear, cargo compartment, or whatever. So for engine 1 and engine 2, I can run the fire wire through those separate areas, but they've got to be isolated so I can tell where a fire is occurring. That makes sense?
Okay, I got.
Yeah. Let me scuttle back up the top there. Just make sure it's not written down there. Now, it might come later, but yeah, a detector for one system is allowed to run through a fire zone for another area, so long as it's not going to be affected by that fire zone. Yeah, your infrared, yeah, alarm sensitivity accurately controlled by a digital circuit now. It's very, very accurate now. Anybody else got any questions, queries? Anything else? Right, we'll go on to smoke detection then. Yeah, smoke detectors dotted about the aircraft in places where there's a potential for fire. So generally, the cargo compartments, the toilets, galley areas, we'll put smoke detectors in. Yeah, they'll give us the quickest possible warning that there's a problem. From your places like your baggage compartment and your cargo area, what we've got is little collectors, as they call them, dotted about the place. And those collectors are pulling air from that compartment through a smoke detector window, a visual indicator. And that visual indicator has a series of, I'm not sure whether I've got a picture, just bear with me, has a series of little windows on it. Yeah, those little windows relate to each compartment. And as air passes through there, if there's any smoke being carried by that air, it will show up in the visual indicator. Yeah, from there through the pipework again, it will run through a smoke detector and then over to atmosphere. Would dump it overboard. If that detector picks up smoke from anywhere, it will set off a warning in the cabin. And then what we do, we have a look at the visual indicator to confirm that we've got a problem, and the visual indicator will tell us which area the problem is occurring in. Because there's not a picture, the visual indicator looks something like that. Has a series of windows in it. Yeah, from pipelines from the different compartments run past the windows. Yeah, and then on out off to smoke detector. Yeah. So let's say we've got a rear freight hold. Yeah, the windows will be marked up as to which region of the aircraft the air is coming from. So let's say we've got smoke detected in the rear freight hold. That smoke will go past a little window, and in the back of the window there's a little lamp. Yeah, as the smoke goes past, it's going to sort of obscure the lamp, so you'd be able to see the smoke passing past that window. That smoke passing past the window is going to activate the smoke detector, and the smoke detector is going to put on a warning light in the cabin. Yeah, some sort of smoke warning. Yeah, the crew can then go and have a look at the visual indicator. Where's that smoke? Have a look at the window. It's in the rear freight hold. And then they can decide what to do from there. Yeah, so that's the basis of our remote smoke detectors, how they're going to operate. Yeah. Yeah, any unused air, any good air, that air continuously being pulled past the detector and the window, and then just vented out to atmosphere once it's gone past. Smoke detectors dotted about the place, as we said before, and they come in all different shapes and sizes. They're not a lot different to what you get in your house if you've got smoke detectors fitted in your house, but because they're for aviation use, they cost a lot more. Yeah. So we're going to put them in the toilets, in the galleys, in the potential hazard areas. Yeah, and they will give just like in the house, they'll give us that audible warning, and used in conjunction with a visual indicator, they will give us a visual window indication. That was what I was trying to draw before. Yeah, the little windows. Yeah, be able to see smoke. Tell you what region it's in. Heat sensitive tape. We can use that. You can see that we had the tape before for the hot air regions following hot air ducting. That was quite high temperatures. With this, it's relatively low temperature that's going to create a change in colour with a rise in temperature. So things like the waste disposal units on the aircraft, in the toilets, for example. If anybody's been having a sneaky cigarette in there, if they've covered the smoke alarm, that hasn't gone off, drop a cigarette end in the if the potential for fire there, the heat sensitive tape will tell us that that bin has been overheated. Yeah, so your smoke detector. Smoke detectors themselves, there are different types of smoke detector. Now, the one that it talks about in the notes, the photoelectric type, yeah, that's one of the most common types of smoke detector that we're going to come across. And how does it work? Yeah, smoke detector consists of a beacon lamp, a test lamp, a labyrinth, and a photoelectric cell. Yeah. Inlet. The labyrinth is just kinks in the tube, basically running through it. We've got a beacon lamp that the air from the cabin will go through the inlet, go past the beacon lamp and into the labyrinth, come out the other side. Yeah. Normal operation, the light from the beacon lamp can't fall on the photoelectric cell that's in there, that sensor. So the beacon lamp shining, yeah, as air passes through, the light from that lamp cannot fall on the photoelectric sensor. If there is smoke appears in the air, as that smoke goes through the labyrinth, the light from the beacon lamp is scattered. Yeah, the smoke affects the path of the light. Some of that light will then fall on the photoelectric cell. The photoelectric cell will detect the change in resistance caused by the light falling on it, and it will send a warning signal off, and the smoke alarm will start activating. To test the thing, yeah, we've got a little beacon light, and that we press a button and the beacon light will shine light directly onto the smoke detector, and again it'll rattle off, it'll start its noise. So that's the internal workings. Yeah, that's your detector, and it's covered in a mesh cage. Yeah, just for protection for it. Not a lot else you can say about that. Anything I've read, yeah. The photoelectric cell, it's the smoke causing the light to scatter, and that scattered light will impinge on the cell and activate the alarm. The ionizing type of detector has a small radioactive source, and that radioactive source is firing off to another contact the other side of the detector. Yeah, the current that's flowing between the two is being monitored. Yeah. If the air has got smoke in it, yeah, it says the small particles of smoke attach themselves to the oxygen and nitrogen ions. Basically, what's happening as the smoke goes through, it's changing the current that's passing between the two contacts. Because that current changes, the detector will pick that up, note the change in the flow current, and set off the alarm. Yeah, so air passes through the chamber, quite normally, not a problem. If we've got smoke in there, that smoke will affect the current that's flowing between the two. I'll call them contacts. I know they're not contacts, but it'll affect the current that's flowing between the 2 points. And once we get to a certain level, certain current level, that will set off the smoke alarm. That's the ionizing type. Yeah, just remember the photoelectric cell uses the lamp. The ionizing type, yeah, relies on a change in current. If you remember that, yeah, if there is a question on smoke detectors, which one's which, then you'll know the difference. Only mentions the two different types. And then I'm just going to read through this straight from the notes. Anything I see, I will let you know. So the efficiency of any detection system, be that fire detection, be that smoke detection, depends on the positioning of the detectors and making sure that all maintenance is carried out properly. Maintenance must be carried out with the AMM. Yeah, be very, very careful when you're working on the thing. Some of the causes of false warnings, ingress of moisture. Yeah, if we get moisture into the system, that can give us a false indication. If we've not installed the stuff properly, that can give us a false indication, short circuiting, damage to the components, that sort of thing. And dirt, yeah, lack of cleanliness can give us false warning. Continuous element detectors, yeah, even though they're protected, you've got to treat them with a bit of respect, handle them carefully. Before you fit any new element, check the part number. Right. Page 40. Everybody got page 40, 40? Second bullet point, the element should be clipped to the structure every 4 inches from the end fittings and at approximately 6 inch intervals along its length. Again, make a note of that, please. Run your highlighter through that bit.
Which one, Jim? Can you say again?
40. Second bullet point. The element should be clipped to the structure every 4 inches from the end fittings and 6 inch intervals along its length. Okay, I've got that. Yeah, inspecting the components, yeah, before you fit them, give them a good look over, make sure that they're not damaged, that any caps, dust caps and what have you been fitted. Intervals prescribed in the AMM, yeah, examine, make sure that there's no defects. If you do find damage, is it in limits? Generally, because it's an emergency system, it's a matter of replacing. Nothing else I can see there. Smoke detectors, your unit detectors. I should say. Again, rigid mounting, just make sure that they are installed properly, that the wiring is not chafing anywhere, that there's no oil or grease or anything. Testing in accordance with the AMM. Electrical tests of fire systems, AMM. Precautions, yeah, just make sure that there's no potential for damage to the stuff when you're checking it. Make sure that the areas have been vented before you start using electric test kit in them for things like fuel fumes and what have you. Nothing we need to worry about there. Nothing we need to worry about there. Nothing there. Functional check, again in accordance with the AMM. If we need to carry out a system functional check, relevant instructions, maintenance of smoke detectors. Yeah, most smoke detectors have got a test button on them. The maintenance for them basically is just to clean them off, light brush, get rid of any dust or accumulated crap. Tesla buttons on the smoke detector. Press the button and the alarm should go off. Yeah. Visual indicator requires no real maintenance. Just make sure that the bulbs are working in there, and just make sure that the windows are clean if necessary. And that was your detection side of things. Has anybody got any questions on any of that? Smoke detection. Right, in that case, we will move on to fire suppression. Yeah, we've got all these means of detecting a fire, detecting an overheat, but what do we need to do if that turns out to be the real thing? So if the fire alarm goes off, yeah, the crew are going to have to decide, have we got a fire? Yes, we have. Right, how the hell are we going to get rid of that? So most aircraft at the various locations, strategic locations, are going to have fire extinguishers fitted and fire extinguishing systems. Extinguishing systems for your engines, your APUs, in the baggage compartments and the cargo compartments. The system made up of cylinders, or what we call the fire bottles. Those bottles will contain an extinguishant of some description. From the bottle, we're going to have the pipe work that's going to take the extinguishant to the area it needs to be. In the system, we're going to have an indicator that we've got the fire, and that indicator is going to tell us whether we've successfully extinguished the fire, and that indication system is going to be resettable. It'll automatically reset, and if the fire reoccurs, again, it'll come back on and give us the warnings. Right, so systems differ from aircraft to aircraft. What have we got then? Let's have a look. We've got our container, the fire bottle, and within that fire bottle is the extinguishant, and that extinguishant is pressurized. Yeah, and it's pressurized so that when we activate it, the pressure behind the extinguishant will force it to where it needs to be. We operate it by fire handles on the flight deck, or in a lot of aircraft, crash switches. If the crash switch operates, the fire extinguishers will activate. And what happens is a small electric charge fires an explosive cartridge. that explosive cartridge will rupture a diaphragm, and that allows the extinguishant to come out. The power supply for the extinguishant on page 48 is 28 volt DC from the Essential Services bus bar. Yeah, and that allows, even if we've lost the generators and everything, we can still operate our fire extinguishers. Most aircraft have got two-shot extinguishing system for the engines, so that cross connects the connections between the individual power plants. Fire extinguishers for each power plant are connected, allows two separate discharges of extinguishant into any one engine. Lots of aircraft, two fire bottles on each engine nacelle, allows two separate discharges of extinguishant into each engine. Yeah, if that's successful, the warning light will extinguish. And as it says on page 48, again, right at the very bottom, some aircraft, we've got special switches to operate the extinguishers in the event of a crash. They're known as crash switches. The two types, the inertia type and the frangible type. We'll look at those, but please make a note of the two different types of crash switch.
Jim,
Yeah.
the electrical supply is different for separate area or not?
No.
Like engine,
No,
APU.
it's all taken from the Essential Services bus bar.
Okay.
Right, just a schematic for what we've got. Your fire bottles, yeah, and on the fire bottle we've got a pressure gauge, and that's telling us how much pressure is in the bottle. I think it is further down in the notes, but again, just while it's on my mind, please just scribble next to that. The way of checking a fire bottle contents is by weight. We weigh the fire bottle, and that tells us that we've got the correct contents in it. Yeah, so the bottles will come out every so often. We'll weigh them and then refit them. And if the weight is within the correct limits, doesn't matter about the pressure that's in there. It's the weight that we look at. I think it tells us later on. So when you're going through. But as I said, just because I've just thought of it, just keep that in mind. At the bottom of the fire bottle, we've got the discharge head. And within that discharge head is the little rupture disc that we were talking about, and the little explosive charge. The little explosive charge called a squib, SQIB. If I've detected a fire, I'll activate the fire handle using a 28 volt supply. That will rupture the little aluminium disc that's in there, and that will allow the extinguishant to flow out from the bottle, yeah, to the distribution pipe. Yeah, distribution pipe from there, it's going to go off and it's going to go to either the whichever engine. We'll come on to that in just a moment. As I discharge the fire bottle, I've got a discharge indicator, and that discharge indicator is a yellow disc that sits on the side of the fuselage. It's like a little yellow piston, yeah. And if the fire bottle has been deliberately discharged, that discharge indicator will protrude forward and indicate that we've done that. These fire bottles are sitting with pressure in them. And if they get subject to excess temperature, that pressure is going to increase. What we don't want is the bottle rupturing, so there is a safety discharge, and that safety discharge line goes straight out to atmosphere via, again, an indicator disc. So if I was sitting on the apron at, I don't know, where it gets very hot. Think of a hot place. Dubai, that gets very hot. Yeah, let's say there's a heat wave in Dubai. The aircraft's out in the sunshine. The pressure in the extinguisher starts to rise and rise and rise. Eventually, the bursting disc, the safety discharge disc, will rupture, and that will allow the extinguishant to escape before the bottle over pressurizes. So inertia switch that we were talking about, there's two types of inertia switch. There's the frangible panel and the inertia switch and the frangible switch. Yeah, the inertia switch is a heavy piston supported on a spring. Yeah, it's arranged so the degree of typical deceleration around about 3G. Yeah, highlighter, page 49, first paragraph. If the aircraft comes to a sudden halt, yeah, if it exceeds that 3G, that bowspring is going to compress. As the bowspring compresses, as the piston, compresses the spring, that releases a bowspring snap over, it says, and breaks the contacts. Yeah, so that bowspring held together, and it's held together by this piston. The piston held in place by the bob weight. If we get a 3G deceleration, yeah, that bob weight will compress the spring it's standing on. This little release lever will let the piston go. That will then allow the contacts to break, and that will fire off the extinguisher. Yeah. If we get, let's say we've been playing football with it while it's in transit or whatever, there's a reset switch, so we can reset it should we need to. Yeah. So if the switch is activated or somebody's knocked it or whatever, yeah, we can just reset it by using the spring plunger there. Yeah, and that holds everything in place. The frangible switch, yeah, it's got two contacts in it, mounted in a sealed glass envelope. Contacts are prevented from closing by a spring. If that glass envelope shatters in the event of a heavy landing or a crash, the contacts will close and activate the fire extinguisher. Yeah, your crash switches normally put in places like the wingtips, underneath the engines, lower fuselage, which are the most likely areas to come into contact with the ground first. And because we've got multiple crash switches dotted about, at least one of them is going to activate the extinguishing system in the event of a heavy landing or a crash, as I say. So those are our crash switches, the inertia type and the frangible type. Yeah, they're both performing the same function, but internally they're operating slightly differently. The discharge indicators for the bottles, a deliberate discharge of the extinguishers to put out a fire is going to activate push a little piston, some pressure from the extinguisher will push a little piston, and that will cause a disc to protrude from the surface of the aircraft skin. Yeah, so that the protruding yellow disc tells us that the bottle has been discharged. The pressure relief indicator disc is a little red rubber disc. And again, if the bottle overpressurizes, rather than creating damage, that overpressure will come down a sensing pipeline. It will rupture the little rubber disc and allow the contents of the bottle to vent out to atmosphere. It is a safety feature. Yeah, so again, Fire extinguisher, positive indication of discharge. Yeah, intentional firing or accidental overpressurization. We've got the pressure gauge on the bottles, so we can have a look at the pressure gauge and see if the pressure's gone right down. We've either got a leak or the bottle's discharged. I'll come on to it in a minute, but on the bottle heads, there's an indicator pin as well that will tell us that the thing's been discharged, and the yellow piston that protrudes from the aircraft skin is another indication that we get. Anything else I need to say there? Ding, ding, ding. Bursting disc locating the operating head. Operated the extinguishing discharges overboard. We've said that. Discharge line opening covered with a disposable plastic disc or a metal disc and blows out if there's a discharge, exposing the red interior of the indicator. Discs are generally coloured red. Certain types of indicator, green discs are used. Yeah, certain types of indicator. Similar system used to indicate if the system's been discharged by actuation. And somewhere I think we have, ta-da! Yeah, that's showing the APU side of things. APU fire bottle pressure gauge, so we can see what the pressure is in the bottle. That's going to give us confidence that the thing's not been activated. If we activate it deliberately, this little yellow disc is going to be forced forward by a piston operated by pressure from the bottle activating, and that disc will protrude from the surface of the aircraft. Yeah, the other one, as we said, we've got the little disc. Yeah, sometimes green. All the ones I've come across have been red. But if the bottle overpressurizes, again, there's a little disc in the bottle ruptures. The pressure from the bottle will rupture the external disc. The shreds of that and the contrasting colour in the housing for that disc will again indicate that the bottle has been activated by an overpressure.
Jim.
Yeah.
Like two discs colored, right? One yellow and other is either red or green.
Yes.
So in both cases, it's protrude outside, right?
Yes, this is the external skin of the aeroplane.
Yes. Can you please explain in what condition in yellow and in what condition is red? Can you explain once?
Yeah, if the pilot or somebody on the ground has operated the fire extinguisher deliberately and discharged the extinguisher deliberately.
Okay.
Yeah. As the extinguisher goes off to where it needs to be, there's a little tapping, yeah, and pressure from the extinguisher strikes the back of the indicator disc, the little yellow disc, and it will push it forward so it protrudes, so it sticks out from the aircraft skin. Yeah, so if we've deliberately operated it, this thing will pop out, and we can see it protruding from the aircraft skin. Okay.
Okay, Jim. For red.
Right. If that bottle overheats, yeah, for whatever reason, let's just say it's been sitting out in the sunshine for 3 or 4 days and it's a really, really hot day and it's a heat wave, the pressure in that bottle is going to increase because of the rising temperature. When that gets to a certain pressure, there's a little foil disc in the bottle head that will rupture, yeah, and that will allow the contents of the bottle to discharge overboard. As the contents of that bottle come down that wee pipe, that pressure is going to rupture the red disc. Yeah, that is just made of rubber or foil or whatever. Generally, it's very thin rubber, and that ruptures. Yeah, and that allows all the extinguishant to dump out overboard. So then what we've got when we're looking at the outside skin, we'll see that disc is broken, and inside the cavity behind the disc, it's also painted. I think it's red. Yeah, so the cavity inside there is red as well. You'll have little bits of rubber disc hanging out. So as you walk around, you'll be able to see that the fire bottle has operated due to overpressurization. You with me there?
Okay, Jim. Thank you.
Sure. Okay,
Yeah.
anybody else? No. Okay. The other picture on there is just showing how the disc protrudes from the aircraft. The piston will push forward with pressure behind it, and it'll just push this forward so it sticks out from the aircraft skin, and it will be really visible that the thing has gone off.
In both cases, it protrude outside, or in the red one, the pressure causes the only rupture, or it also protruded out.
This is a little piston. Yeah. So what happens if as the bottle operates, if that's your aircraft skin, the little piston is going to protrude from the aircraft skin. Yeah, so
Okay.
that yellow piston will stick out.
Okay.
Yeah, with the indicator disc. Yeah, if that's your aircraft skin, there's a housing inside. The pipe comes into the housing, and you've got the red disc, keeps everything flush. If that disc ruptures, yeah, so we've got an overheat, that disc will rupture, so we'll get bits of rubber flapping about everywhere, and the interior of this compartment is painted generally red, so it's a contrasting color. So as you're walking past the grey skin, yeah, you'll see little bits of rubber dangling about, and you will see the contrasting red area inside behind the disc, and that will immediately attract your attention, and you will know that the fire bottle has discharged due to an overpressure.
Okay, Jim.
Okay with that?
Thank you. Okay.
That's all right. Anybody else? Right, extinguishers themselves, yeah, different types of construction made from corrosion-resistant steel. Older aircraft, they use copper. Depending on the type of extinguisher, we have a dual or a double discharge, a single or a double discharge head. Within the discharge head, we've got the cartridge, the discharge ports, an indicator pin, the thermal disc, and a connection to the discharge indicator, which I will show you now. Ta-da! Right, a typical fire bottle. Within the fire bottle, the container, we have the extinguishant, and that extinguishant is pressurized. Yeah. At the bottom of the bottle head, there is a little frangible disc, yeah, a little sort of foil disc, if you like, that's keeping the extinguishant in the container, keeping it under charge. Below that, in the operating head, in this case, we've got a dual discharge head. Yeah, the dual discharge head is directing extinguishant to where we need it to be. At the end of the discharge head, there is a little indicator pin, and what happens when we fire off the bottle, some of that pressure just pushes down on the head of that pin. That pin will protrude, So when we're carrying out our inspections, we'll see that the pin's protruding. Normally it's flush. If it's sticking out, it means that the bottle's been activated. That disc, we said above a certain pressure, as the bottle over pressurizes, the disc will rupture, and there's an outlet to the red disc, and the extinguishant will vent overboard. So that's what that's there for. That foil disc, so long as everything's at the correct temperature and the correct pressures and all the rest of it, that disc is going to keep the contents inside the bottle. Should we have a fire, we want to release those contents, and we do that by firing a little explosive charge. The little explosive charge known as the squib. Yeah, activated electrically, 28 volt DC. As we put the electrical charge in, the explosive goes off and it ruptures the disc, and that allows all the extinguishant to flow out of the bottle to where it needs to be. Some bottles got a pressure gauge on them, so we can see what the pressure is in the bottle. Gauge indicates the internal pressure of the bottle. Yeah. Sometimes, yeah, there's a pressure switch in there, and when the pressure decreases, it'll put on a discharge light in the fire handle, or on a bulb adjacent to the fire handle, so that the crew know the extinguisher's been operated. Pressure switch, part of the pressure gauge, so you've got to replace the whole bottle if you think the pressure switch is iffy. Thing normally pressurized to, it says to around about 600 psi, but I wouldn't worry too much about that. Extinguishing agent released, as I said, by a cartridge or the squib, ruptures the disc, and away the extinguishant flows. Dooby-doo. Yeah, so typical sort of fire bottle. Yeah, discharge heads, the electrical charge to the squibs, squib fires, extinguishing out and off to where it needs to be. There'll be a pressure gauge on there, and then you've got your overpressure line out to atmosphere should the bottle overpressurize. Yeah. So again, yeah, thermal discharge, yeah, overpressurization. Pressure gauge with the low pressure switch in, so that will put on a warning light in the cabin if the bottle's been discharged. The head of the bottle, yeah, we've got the discharge port where the extinguishant's going to go. We've got the little frangible disc, yeah, and we've got this squib, the explosive cartridge. As I podge the button or pull the handle or send an electric signal down, the cartridge will explode and it will cause that disc to rupture. Now all of your extinguishant can go off to where it needs to be. In the bottom of the head, there's a little strainer. So any bits of the disc that float free will be caught by when they talk about the strainer, it's a little filter. It's not going to stop the extinguishant, but it'll just trap any bits of disc that might have broken free. The other thing we've got in there is a drain valve. What we don't want is moisture in the system, and moisture with the electrics and the cartridge. So within the bottom of the bottle head is a drain valve, and that drain valve is normally in the open position. If the bottle discharges, if we fire it, the pressure from of the extinguishant coming out is going to close that check valve, that drain valve, so none of the extinguishant will escape through it, but it'll prevent moisture from building up. DC voltage 10 to 29 volts, minimum of 3 amps is required to fire each squib. Yeah, so it's a very small charge. Yeah, cartridges are fired by the fire handle. Check valve, drain valve that I've just talked about helps prevent misfires due to accumulating of moisture. A type of non-return.
Excuse me, Jim.
Hello?
Jim. Sir, please can you explain the second shot, sir?
Can I explain what?
The second shot, sir. Two shots.
I've not got to that yet.
Yes, sir.
You're reading ahead of me, aren't you?
Oh, no, sir. I think you have left, sir.
No, we've not got to two shot yet.
Okay, sir. No problem.
Okay.
Sir. I will. Okay.
What we've got between our engines, are crossfeed pipelines between the extinguishers. So if I have a fire, let's say left-hand engine, I've got a fire, I will operate the fire bottle. I'll go to position 1, and position number 1 will fire the extinguisher. That extinguisher will then discharge into the left-hand engine. Yeah, as it extinguishes into the left-hand engine, hopefully we'll put the fire out. This little valve here, the directional flow valve, I might have a picture of it comes up, but just in case, is just a little valve like that. Yeah, and in it is a piston. And what happens as I fire the bottle, as the extinguishing comes up this way, it shoves a little piston across to seal off this outlet. So now the extinguishing is going to go straight up to put my fire out here. If that hasn't put the fire out, I've fired off my left-hand bottle, what I'll do is go to the right-hand switch, select the number 2 position, and that will go to the right-hand switch, select the number 1 position, my apology. That's going to fire off the right-hand extinguisher, and as the extinguishing comes across from the right-hand side, it pushes this little piston over, seals off that entry port, and now extinguishing from the right-hand side can flow around the left engine. So we've got that cross connection facility. So we can use the right-hand extinguisher on the left-hand engine. We can use the left-hand extinguisher on the right-hand engine. What I should have said there was that the number 1 switch for the left-hand engine fires the bottle straight to it. If I go to the number 2 position, I'm going to fire the right-hand extinguisher, and that is going to feed right-hand extinguishing into the left-hand engine. Can you all see that? So left-hand engine fire warning, left-hand switch, fire bottle into the left-hand engine. Fire doesn't go out, I'll select the number 2 switch. That'll go up to the right-hand extinguisher, and it will take extinguishant from the right-hand extinguisher and fire that into the left-hand engine. Everybody okay with that?
Hello, Jim.
And the same for the right-hand side. If I get a fire in the right-hand engine, select number 1 position. That will directly go up to the right-hand engine. If I select number 2 position, that will fire the left-hand extinguisher into the right-hand engine.
Hello, Jim.
Hello.
So one shot, one bottle, 2 shots. There are 2 shots in one bottle.
Not in this case. No, what we're doing is we're using 2 extinguishers.
Okay.
Yeah.
No, you there in one there are 2 squibs in a bottle.
Yes.
So there are 2 shots available from one bottle.
No.
No.
You've got 2 heads. Yeah.
Okay.
You've got 2 squibs. Yeah.
Okay.
This head, for example, will go to the number 1 engine.
Okay.
Yeah. So if I've got a fire in the number 1 engine, I'll turn the fire handle to the number 1 position, and that will fire the squib, and it will discharge the extinguishant to the left-hand engine.
Okay.
If I've got a fire on the right-hand engine, yeah, so I've got another fire bottle over here. I've got a fire on the right-hand engine, exactly the same thing. I select right-hand engine, the fire bottle activates, and it doesn't put the fire out. So with the right-hand handle, yeah, I can select the number 2 position, and by selecting the number 2 position, that is going to fire the squib, and that is going to allow the extinguishant to go from the left-hand bottle to the right-hand engine.
Okay, Jim. Okay, got it. Thank you.
Can you see that?
Okay.
Is that okay?
Jim,
Okay, Jim.
Jim, what about multiple engine, more than 2 engine? Is there like in 4 engine aircraft? Can we have a 4 selection point for the switch? Otherwise, how can we cross-fit to the several engines by a different extinguishing agent? Sorry, extinguishers.
If that's your aircraft with 4 engines, yeah. All we're going to do is the same setup. Yeah, we'll have a fire bottle for that engine, fire bottle for that engine, one for that engine, one for that engine. So if you get a fire on this one, yeah, we'll activate the fire switch. If that doesn't put it out, we can use the fire bottle from this engine for there. Yeah, same thing, if I've got a fire here, yeah, I can use the fire bottle from this engine as a second go for that engine. What you won't get is this one feeding over to this one.
Yes, is it not possible?
Well, it's possible, but it's starting to complicate everything. Yeah. If you keep them adjacent to each other, it's a lot easier. It keeps the system simpler. Yeah, and you're not jeopardizing your other engine protection as well.
Okay, Jim.
Yeah, it'll be something along those lines. I'm not saying that'll be it exactly, but it'll be something along those lines.
Hello, Jim.
Yeah.
In one engine, there is 2 fire extinguishers, right? Generally.
Where am I? In the example that we're talking about, yeah, there's 1 extinguisher per engine.
But in one engine, I think there are 2 extinguishers. If there are 2 extinguishers in one engine, sir, then if you select number 1 switch, then it can discharge both fire extinguishers from the same engine.
You've lost me. No, stick with the example that we've got. Let's not complicate it. On this one, we've got a fire bottle. Yeah? Okay. If I get a fire in my left-hand engine, yeah, I want to put that fire out. So what I'll do, I'll get my fire warning. I will select, yeah, the number 1 position. Number 1 position will fire the squib on the extinguisher, and that extinguishant will go out into the engine and hopefully put the fire out. If it doesn't, yeah, what I'll do is select the number 2 position for the left-hand engine. Yeah, that will then operate the squib on the right-hand extinguisher, which will then send extinguishant through the cross connector into the left-hand engine. So the left-hand switch, yeah, if I don't get the fire extinguished with the first shot, I can select the second position, and that will use the right-hand extinguisher to put the fire out on the left-hand side.
Okay, sir, I got the point. But sir, I want to know that because in Airbus 320, sir, there was in one engine there was 2 fire extinguishers. That's why I asked.
There's no reason why not, but you know that is aircraft specific, isn't it?
So just I want to know that if there is 2 fire bottle in one engine, is it necessary for connection for the both engine?
For the cross connection, I wouldn't have thought so. I don't know Airbus. I'm not an Airbus engineer, but I wouldn't have thought if you've got 2 extinguishers on one engine, I wouldn't have thought there's any need for cross connection. No.
Okay, sir. That's why I know, because if one engine there are 2 fire bottle, then it is a compulsory connection for the cross connection for the other engine. That's
you'd honestly have to look at the manual for that aircraft type. I couldn't tell you off the top of my head. I've never worked on them. Okay. But as a guess, if you've got 2 bottles on one engine, I would say that will be sufficient. But you know, that's up to the designers.
Okay, sir. Okay, sure, sir. Because this is for the standby only,
sorry,
sir,
that's
right?
fine.
Yes. Okay, sir.
Right, nothing else we need to know there. Yeah. And on the diagram there, it's calling it a 2-shot fire extinguisher system, which personally I'm. Let's just see if we come on to that. That's your fire control panel. We talked about that before with your engine extinguisher switches. Yeah, what you do, you pull the switch to arm it, turn it through 90 degrees to activate it. So it's a 2-shot thing. It's a conscious decision by the crew to operate the extinguishers. So to arm the extinguisher, we pull the handle at the first position, then twist it through 90 degrees. That will fire the squib off. Test switches, so you know that the system's working, yeah, and your discharge indicator just to let the crew know that the relevant fire bottle's been discharged. We're going to look at cargo compartments in just a second, but this is a fire panel for a cargo compartment. Yeah, auto, or we can have the forward area or the aft area. Yeah. And again, to arm it, we're just going to pull the switch and then make the selection. Automatic, it should go off. The fire suppression, yeah, is a guarded switch, so we've got to lift the cover up. And again, it's a deliberate decision to push the button. Yeah, and indication to tell you that the bottle's ready to go. And the warning bell cut out there. 2-shot system. Yeah, again, 2-shot system. This is this little piston check valve that I was trying to describe to you. If I discharge my number 1 container, yeah, the squib will fire off. That will then fire that little piston over, shut that off, and the extinguishant will go to the number 1 engine. If that doesn't put the fire out, I can fire off the second position. That again will activate a squib. Yeah, the second shot for the number 1 engine. yeah, the extinguishant will discharge. As it goes through, it'll push that little piston over, yeah, and send the extinguishant out to the number 1 engine. So I've got number 1 engine, yeah, and I've got a second shot to the number 1 engine. Should I need it? Exactly the same principle for the right-hand engine. Yeah, fire that, fire the squib, piston moves over, extinguishant straight off to the number 2 engine. If that fails, take the next shot, the second shot for the number 2 engine, fires the squib, extinguishant, pushes the wee piston over, and extinguishant off to the number 2 engine. Easy peasy lemon squeezy. 2-shot extinguishers. Cargo compartment. Yeah, again, we can do the same sort of thing. 2 fire bottles in your cargo compartment. Forward cargo bay, aft cargo bay, and again they are both cross-connected. So if one doesn't do the job, I can use the second extinguisher, and so forth. The extinguishant, yeah, is sent to the areas via, again, it's sort of piccolo tubes. It's just pipe work with little holes drilled in it. And by doing that, we're going to make sure that there's a uniform application of extinguishant in that area where we want it. The dual discharge, yeah. Anything in the cargo? No. Amount of extinguishant in the cargo bottles sufficient to extinguish any existing fire and provide sufficient concentration of extinguishant to suppress for a period of time. Yeah. Again, it just goes through the discharge procedure, and we can see that. Nothing there that we need to worry about. Squibs, yeah. I'll come on to those in just a second. Squibs, two-stage fire extinguishers. And what we've got is an outer cylinder and an inner cylinder, or it calls it outer volume, inner volume here. The purpose of these things is to provide an initial shot of extinguishant. So if I fire the extinguisher, yeah, the initial amount of extinguishant will come out and it will get sprayed into wherever it needs to be. Yeah, so we get that. Then the second volume of extinguishant is eking out through a small orifice and again going to the outlet. But because it's going out through an orifice, it's coming out slower. Yeah, and the idea behind that is that the initial squirt should put the fire out, and the second volume should keep the fire suppressed. And they reckon that you can get about 30 minutes protection from that. So it's a container within a container. Yeah, fire extinguishers discharged. Outer container flows out immediately. Inner container leaks out at a controlled rate and suppresses the fire. Okay with that? Different types of extinguishant we might come across. Methyl bromide, yeah, no longer in use. You might find it on older aeroplanes. It comes in a bluey bottle. It should all be out of use now. Yeah, we don't use it. Methyl bromide. PCF, yeah, very, very good fire extinguishant. Yeah, effective against electrical and liquid fires used in the engines and the APU. Yeah, also known as Halon 1211. So Halon 1211, even though Halon extinguishers are banned, there is a clause that says that airlines or aircraft can still carry on using Halon until a suitable replacement has been discovered. At present, that hasn't happened. So a lot of aircraft still flying around with halon extinguishers in them. Halon 1301 or BTM, bromo trifluoromethane. Yeah, another type of extinguishant used generally in cargo compartments. Yeah, see 1211 and your 1301. Both halons, both still authorized for use on aircraft. Anything I need to say on the maintenance? Yeah, before installation, yeah, inspect your fire bottle. The weight check that I was talking about, so that'll be on page 61, second bullet point. Yeah, make sure that we check the extinguishers by weight. Right, page 61. Yeah, make sure that you make a note of the fact that your cartridges have a 5-year storage life, but they've only got a 2-year installation life. So they need to be checked to make sure that they are within date before they are fitted. Cartridge units contain gunpowder, should be handled with extreme care. Some cases, and again make a note of this, some cases conductive rubber plugs known as shunts must be fitted to the electrical connectors when the cartridge is detached from the extinguisher. Yeah, so if we take the cartridge out, the electrical connector has to have that rubber plug put on it, that rubber plug known as a shunt. The cartridge itself known as a squib. Make a note of that, please. Page 61. Yeah, so there's 2 big highlighters on there. The cartridge life, yeah, and the shunts. Nothing else we need to worry about there. The pipes on the extinguisher, yeah, are just pipes with the holes drilled in them, spray rings as they're called, just a form of piccolo tube, as I said. And we just need to make sure that they're not blocked. Yeah, just make sure that they're not locked up, blocked up. Yeah, that's your cartridge units, gunpowder, shunts. Yeah, the little rubber plugs that we fit over the electrical connectors, and make sure that the cartridge life hasn't been exceeded. Check the pipes. Nothing else there that we need to worry about. Discharge indicators, just make sure that they're intact and haven't been operated. Check the contents by weight. We mentioned that, and we've mentioned that again now. The extinguisher should have its own record card, so we're going to make a note of what the weight is on the card. And those extinguishers will come out periodically for maintenance. And again, when they come out, when they get refitted, that's going to get recorded on the record card. System tests, all I would say is read the AMM. The systems are aircraft peculiar and different operating methods, that sort of thing. So any testing needs to be done strictly in accordance with the maintenance manual. Extinguishers stored out of direct sunlight, otherwise you're going to get pressure build-up. Yeah, check the weight. Yeah, cartridge units stored in polythene bags in a moisture-free atmosphere, kept away from sources of heat. Yeah, labelled with the life of the thing on it. As soon as that cartridge unit removed from its bag, the life expiry date is 2 years from the date of removal. Yeah, so long as it's in your 5-year storage period. Ta-da. Anybody got any questions there? Easy enough. If we've had to operate the extinguishers at all, there are certain things that we need to do afterwards. If we've operated the extinguishers in flight, yeah, we don't need to clean the engine because the throughput of ram air through the engine will have done that for us. If we've operated the extinguisher on the ground, yeah, we need to make sure that we open the cowlings, vent the engine out for at least 30 minutes. Any pools of extinguishant that we find, we've just got to mop them out with a cloth. If it's a dry powder extinguisher, yeah, open the coals and use a vacuum cleaner. Don't use water on dry powder. It'll just turn all gungy and gooey and horrible. If it's a foam extinguisher, yeah, rinse with water until all the foam's gone. If it's a CO2 extinguisher, just open the cowlings and ventilate the engines. If you've got CO2 extinguishers, yeah, it's very, very cold. If you've squirted that on hot engine parts, it might need to carry out additional checks for cracking, that sort of thing. Internally for the engine, yeah, if we fired the extinguishers, dry run the engine. Yeah, if you can start the engine, run it for 5 minutes just to blow everything through, blow it all out. Says if it's dry powder activation, remove the engine to make sure, disassemble it to make sure that all the powder's been removed. Same with foam, remove, and if it's CO2, again, just crank the engines up and run it till all the extinguishants blown away. Bits that we need to remember there, yeah. Extinguisher operated, if it's in flight, we don't need to take any action. Yeah, if it's on the ground, yeah, if it's CO2, we just need to ventilate everything out. Yeah, dry powder, pick up with a vacuum cleaner. If it's internal, the internal cleaning, just remember the only exception is CO2, where we can run the engine to blow it through. If we've used anything else, we need to remove the engine, disassemble, and clean and inspect it. Last type of extinguisher that we're going to find on our aircraft are portable fire extinguishers. Your portable fire extinguishers, the handheld extinguishers, yeah, that we can use for fires in the cabin, fires in accessible areas. Yeah, so there are going to be different quantities of extinguisher depending on the aircraft, depending on the passenger numbers, dotted about at easily identifiable locations. We've got to be able to see where these things are. We've got to be able to get hold of them. CS25, yeah, CS25 stipulates the requirements for the number of handheld extinguishers. Minimum number carried depends on passenger capacity. That's passenger capacity, not the number of passengers you've got on board. Yeah. So if your aircraft is carrying or capable of carrying between 61 and 200 passengers, you've got to carry 3 extinguishers minimum of. Yeah. If you carry between 400 and 500 passengers, minimum of 6 extinguishers. Each one readily accessible, mounted so as we can get it out of its stowage quickly. And unless it's clearly visible, the location of your handheld extinguishers should be identified.
Do we need to remember the number of extinguishers?
I don't actually know. I've not seen a question on it, but that is not to say that there isn't one. So the honest answer to that is I genuinely don't know. If it was me, I'd be more inclined to remember that it's on the passenger capacity. Yeah. So the higher the capacity, the more extinguishers you need. If you start at 30, and remember, if you've got maximum of 30 passengers, you've got 1 then if anything came up, you could work it out. Yeah, but I would personally say the minimum number, I'd be remembering that depending on capacity rather than the amount of passengers that are actually on board. Does that kind of answer your question? I know it's not the right answer, but it's the honest answer.
Thank you.
Yeah, at least one extinguisher in the pilot's compartment, one at the Class A, Class B baggage compartment. Those are the areas that the crew can get to. Yeah, so if there's an area that the crew can actually reach, then there's got to be a handheld extinguisher available should they need it. One at the galleys. At least one located in the passenger compartment of an aeroplane with a capacity of 31, not more than 60. Two, 61 or more. And there must be halon 1211 or equivalent. So halon extinguishers in there. Halon extinguishers in the passenger compartment, depending on the number of passengers that you're capable of carrying, depends on how many extinguishers. If you carry up to 30 passengers, 1, 62, 203, and I wouldn't bother my arse on any more than that, quite honestly. And I think, guys, that was that. Only maintenance we can do is just make sure that they've not been discharged, that the things are in date, and that the pressure indicator is in limits. And that, guys, was fire protection, detection and suppression, and I can't think of anything else there. Anybody got any questions on any of that little lot? No? Right, that was the end of our common systems. That was the last little book that we needed to do with the common systems. The B1.1s and the B.
Excuse me, Jim.
Yeah?
Can I ask one question for you?
Yeah.
If there is 30 passengers in the aircraft, how many fire extinguisher bottle should be there in the whole aircraft?
One handheld extinguisher.
One is for the whole aircraft, or only in the passenger compartment?
For the whole aircraft. Normally, there's one in the flight deck. Yeah, so we'll say one in the passenger compartment. But the requirement is to carry one handheld extinguisher. You've got to think 30 passengers. You're not looking at a big aeroplane, are you?
Okay, thank you.
Okay.
Okay.
Anybody else? Right, that's the end of the common systems for all of us. At this point, the helicopter guys are going to separate, and they're off to do whatever helicopter guys do. Yeah, the B1.1s and the B2s are with me for the next week doing the 11-13 subject. Now, if the helicopter guys haven't got any questions, that's me finished with you. The B1.1s and the B2s will come back this afternoon, and we'll just have a quick look at water and waste. It doesn't take long. It's not complicated. Very, very simple. So we'll do that this afternoon. The B1.3s, the helicopter guys, we don't need you. However, after I've finished everything on the 3rd of February, I think it is, the 3rd of February. What we'll do, we'll all get together and we'll all get together and we'll have a recap on all the different subjects. And we can do that. Yeah, what we'll do that during the whole day. So, yeah, this afternoon, this is where we've finished the B1s, B1.3s, the B2s. All those common subjects are now completed for us. This afternoon, the B1.1s and the B2s come back. Yeah, after 1 hour, 13:30 my time, 1 hour, and we will have a quick look at water waste. The B1.3s are finished with you. Then on February the 3rd, yeah, if everybody can make it back, there, or what might be better? The B2's there. Yeah, is everybody able to make it back on the 3rd of February? Would you be able to join me for a class then?
Yes.
Yeah.
Yes, sir.
Okay.
Yes, Jim. Yes.
Yes, sir.
Fantastic.
time
Well, if
we have
everybody
to-
can make it then, put that down in your diary. We'll have that 3rd of February, that last day. We'll have that as a revision. We'll go over everything that we've done so far. Yeah, and I will cover every subject for all the questions that you want to fire at me then. So that gives us a good day of revision at the end for everybody. Is that okay?
Okay, Jim.
Yeah.
Yeah.
Okay, Jim.
Okay then, so the B1.3s, thank you very much for your time and attention. I hope you've got over your initial, he's not telling us what we need to highlight. Yeah, hopefully I've taught you what you need to know. Hopefully we've pointed out the important bits. If you do want to put feedback in, if you're happy or you're not happy or you're only a little bit happy, if you want to put any feedback in at all, please do so. Yeah, I'm a big boy. I can take the criticism. If there's things that you think could have been done better, done differently, put your feedback in. You can put it in through Sanjay, or you can use the AST website, or you can email one of the managers at AST if you so desire. But don't be shy. If you want to put feedback in, please feel free. So the 1.3s, I will see you on the 3rd of February. Yeah.
What time? The same time or the time differs?
We'll go with the same time. We'll go at well, it's 9:15 my time. I'm not sure what time it is in yours. About 3 o'clock, is it?
Okay. Okay, thank you.
Yeah, just the usual morning start time for whatever time you normally start.
Excuse me, Jim.
Yeah.
Can I ask one question for you?
Yeah.
When I've already asked that, how many fire extinguisher in the aircraft having 30 passengers? You said 1, yeah?
According to the notes, yeah.
But it doesn't require in the cockpit and cargo?
No. Well, on a 30-seat aeroplane, you're not going to have anywhere you can get to. Yeah. So CS25, the requirements for the carriage of handheld extinguishers, the minimum number is dependent on the passenger capacity. Yeah. So depending on the amount of passengers you've got depends on the amount of extinguishers you need to carry.
Only handheld. It's the only portable fire extinguisher, right?
That's just for the portable. That's just for the handheld.
Apart
What
from
I would,
this,
what I would say on most aircraft, although that's the regulation, if you're carrying 7 to 30 passengers, yeah, you're only obliged to carry one extinguisher. I would say that would be in the passenger compartment, because normally there's going to be a separate extinguisher in the flight deck.
Excuse me.
Yeah.
Can you explain about relief valve?
What relief valve?
Relief valve in the fire bottle. I just want to know that if the pressure in the bottle is high, then does the relief valve discharge all the fluid or not?
Right. That bottle is under pressure. Yeah.
Yeah.
The pressure and the extinguishing is held in by a little disc. Yeah, just a little disc. If the pressure increases due to heat building up the pressure, that disc will rupture. Yeah, and that disc rupturing will direct all the extinguishant overboard. Yeah. If I fire the bottle, if I discharge it deliberately, I'm rupturing that disc by using a little explosive cartridge. And as I use that explosive cartridge, the extinguishant is going to be directed to its overboard. Yeah.
Can you?
This one, the relief disc is set up slightly differently. Yeah, so the relief disc will be behind this port here. This port will be connected to the outside. Yeah, so different types of bottle, but the principle's the same. There's a little bursting disc. When the pressure gets too much, the disc will rupture, and there's a line straight to overboard.
Yeah, it means that during overpressure condition, all the fluid will discharge through all relief valve pin also.
So say that again. Sorry, I can't hear you.
Yeah, during the overpressure condition, do all the fluid discharge from the relief valve then?
No, it's only if the pressure builds up. If that pressure in there becomes too much, yeah, if we didn't relieve it, then the bottle would explode. So that's why you've got the little bursting disc in here that will just direct all the extinguishing overboard.
Yeah. Okay, Jim. Thanks. Thank you.
Yeah, but under normal conditions, the pressure is sufficient. The bursting disc will contain that pressure. Yeah, it'll only rupture at a certain point.
Yeah. Okay, I got it. Thanks.
Are you sure?
Yeah.
Okay. Anybody else got any questions? Right. In that case, I will see the B1.3s on. Yeah. I thought someone was shouting at me. I'll see the B1.3s, the helicopter guys. You come back on the 3rd of February, usual start time, and we'll have a big recap of everything. The B1.1s, the B2s, 1 hour. We'll come back in 1 hour and we will have a quick look at water waste.
Okay, thank you, Jim.
Everybody all right with that? And again, the B1.3s, if you want to stick feedback in, please feel free. Other than that, I will look forward to seeing you in a couple of weeks.
Okay. Thank you for all your classes.
Okay, no problems, no worries.
And thank you for clearing all my doubts one by one. I ask lots of questions.
Yeah, well, hopefully we've answered them, and now you've got all the answers.
Yeah, thank you.
Okay. Right, I'll see you guys after lunch then.
Okay,
Yeah,
sir.
1 hour. Okay, cheers. If any of the B1.3s, any of the helicopter guys, if you have got any questions and you want to ask them, come back after lunch and I'll try and do those before I start with the other guys.
Okay.
Okay. Thank you, Jim.
Okay.
के छ योबाट कस्तो किसिमको छ सम्भावना?
Mike.
Hello, everybody. Hello, Yadav. Are you okay for distributing the questions to this group as you did for the other one?
Yeah, I'm okay.
That's wonderful. Thank you very much indeed. I'll get some questions from this morning's subject to you and this afternoon's subject at some point. This afternoon's subject is really small. There's not a lot to it at all, but I appreciate you doing that. Thank you very much indeed.
Okay, sir.
The only other issue I've got, and I did ask Sanjay this morning just to make sure that I'm included on the invitation for the lessons for the upcoming week.
Yeah, he will do it.
Yeah, I asked him this morning. It's just if I don't appear tomorrow, you know why. He's not sent it. Right. Righty. Puspa, you've got your hand up. Is there something you want?
No, sorry.
No. Okay, then. You're just waving to me, saying hi. Right then, guys. A really easy afternoon for you. We're looking at water waste systems on the aircraft. And in all honesty, there is not a lot to them. There's not a lot that we need to worry about with water waste. What we're looking at, we're looking at the water that we're going to carry, how we're going to get it to the taps, how we're going to treat the systems should we need to, and then we'll look at toilets very quickly, my favourite subject for a Monday afternoon. So the first part of it is the water systems, how we're going to get the water there. And as I said yesterday, and it's worth noting, potable water is the term commonly used in aircraft to describe, or in the aircraft engineering field. It's what we use to describe as water fit for drinking, potable water. So that potable water, when we load it onto the aircraft, it'll go into big tanks, and theoretically, not only can we drink that water out of the taps, we could drink it out the toilet if we wanted. It's fit for consumption. That is theoretically. I am not recommending that we go around drinking toilet water. But potable water, again, squidgy highlighter through there, just so you know that it is water that's considered fit for drinking, fit for human consumption. That water kept in tanks, and depending on the size of the aircraft, obviously depends how much water that we're going to carry. Your 737, different variations of the aeroplane, and different sized water tanks that we're going to keep on the aircraft, just there for an example. So the capacity of the water varies from aeroplane to aeroplane. Where are we going to send that water to? We are going to send it from the tank into the collector tank, and from there we'll go to the galleys, the little drinking fountains that we've got, the toilet, lavatory wash basins, and the toilet itself. The waste side of it, is slightly different. Normally, with our aircraft nowadays, any toilet waste gets recovered to a collector tank in the aircraft. All your sewage goes back to the collector tank. And then when the aircraft lands, somebody goes along with a honey truck and empties the toilet tanks out. The wash basins, drinking fountain, the galleys, the wastewater either has a collector tank, or we can evict it overboard to atmosphere, because it's just Essentially, it's just liquid, just the water that we're dumping off. Somebody beeping. Yeah. We're all in. Aaron in. And if you just bear with me 2 ticks. I'll just open the notes, and again, I'll do that just to make sure that I'm not missing anything. So we've done that. Yeah, potable, fit for drinking. You've highlighted that. Purpose of the system: supply water for drinking at the galleys, hot and cold water to the wash basins and the toilets. 1 or more systems usually provided, but it depends on the size of the aeroplane, and away we go. Ta-da. Yeah, water tanks themselves. Yeah, again, depending on the style of the aircraft, depends on the size of the tank. This one just an example. But the tank's generally made from fiberglass. Some older aircraft use stainless steel tanks, but the weight penalty for the stainless steel nowadays, we're using lighter materials, allow us to carry water. Again, make a note of the fact that those tanks are insulated during flight. They're kept warm. We can either pump warm air from the air conditioning system into the tank compartment, or the tanks might have a heater blanket fitted around them. What we don't want is the water freezing at altitude, so we need to provide that warmth to the tanks. Yeah, so normally we're going to duct hot air from the air conditioning system around them. If we haven't got that facility, we can wrap them in insulating blankets with a little heater element in. Tanks, in this case, we've got individual tanks, individual little water tanks rather than one big one. Yeah, and those tanks are topped up from the water service panel. The water service panel allows us to fill and empty the tank should we need to from there. So just a connection down below, and from that one connection, each of the tanks is individually filled up. Anything else I need to say there? Not really. Yeah. Top the tanks up. Yeah, water service panel. Yeah, and we're gonna send the water up, and then the individual tanks will be filled from a fill line. You'll notice we've got a vent line in the system, and again, the vent line, exactly as we said for the hydraulic side, it'll allow us to put a little bit of positive pressure so that the water is going to get forced along to the taps. It will also compensate, so as the water is used and the tank empties, I should say, then the fact that we're putting a vent in there is going to prevent the tank from imploding on itself. Yeah, so it protects the structure of the tank as well. From the water tanks, yeah, we'll go off to distribution lines, taking the water to where we need it to be. Yeah, so just an example. As I say, we need to provide a little bit of positive pressure on the tanks, so we can send that water. It's going to run down to the taps as it should. Now, depending on the type of aircraft, we can either put a permanent charge on there, so top it up from the ground. Some aircraft will use a little compressor, exactly as we saw yesterday, just chugging away, providing pressure. Other aircraft will use bleed air, yeah, tapping from the bleed air system, and that's going to put the header pressure on the tank. If we use a compressor, Yeah, the compressor, the line to the tank has what they call a riser loop in it. Yeah, so that the feed from the compressor goes up the way first and then back down to the tank. And the reason for that is to prevent water from siphoning back into the compressor, because water can't run uphill. Yeah, that's why we put the riser loop in there. It's to prevent water from siphoning back into the compressor. And that is on page 7, just below the diagram, the same diagram that you're seeing. What else do we need to say? Yeah, pressurizing air, compressor, riser loop. Yeah, so your compressor is going to run. Yeah, set to a particular value, send its pressure up via the riser through a non-return valve, and again that just makes sure that the air can't return into the tank, and it's going to sit there with a headed pressure on the tank. Pressure switch is there to cut the compressor off if we not cut the compressor off, cut the system off if we get too heavy, and a little pressure relief valve in the system just to prevent overpressurization of the tank. If anything goes wrong, yeah, we've got the pressure switch there. I'm just trying to think if the pressure switch, I think it puts on a warning light in the cabin if I remember rightly, but I can't remember off the top of my head. But we've got a pressure relief valve in the system. That's going to prevent overpressurization, and then that water is away to the manifold in the distribution line. That's it. Pressure switch, stop and start the compressor as required. So once we've reached the operating pressure, that'll cut the compressor off. The compressor's not fitted Schrader valve. We talked about that, and it just allows us to pressurize the tank there from the ground, and the header pressure maintained. Yeah. So how we're going to get water into the aeroplane? Yeah, from a big tank. Yeah, the tankers provided bring clean, sanitized, potable water to the aeroplane, and we connect up to the water service panel to put that water into the aeroplane. Once we've got it into the tanks, then it's going to be distributed through the aeroplane, and this again is just an example where your water is coming from your manifold, and it's going off to the loos at the back of the front. It's going up to the galleys at the front of the aeroplane. There might well be a drinking fountain on the aircraft. Yeah, so we'll duct water to that as well. We'll just distribute it to where it needs to be. Yeah. So your water bowsers, if you like. Yeah, water bowsers, all different shapes and sizes. Yeah, but so long as that water's been treated, it's fit for drinking, then we can pop it in the aircraft. The water service panel adjacent to the tanks, and all we're going to do is take a pipe from our potable water, connect it to the system, and fill the tanks up. The tanks are generally on a fill to spill basis, which means that we're going to put more water in. We're going to fill the tanks up, and we fill them to overflowing. It's very, very rare that we'll put a specific quantity of water in. Normally, we'll just fill them to the gunwales. Toilet water supply, typical water supply. Sorry, just getting ahead of myself there. The service panel, yeah, again, we'll look at that. We have got a quantity indicator, but as I say, normally we'll just fill till the tank's full. a drain handle, so we can drain the tanks if we need to, and a fill valve. Yeah, unlock that, open it up, and from the fill connection, we're going to push water into the tanks. Yeah, once that's been accomplished, yeah, we'll just close the fill valve again, and away we go. Make sure that we've got sufficient water. Ta-da! Toilet water supply, yeah. So as we said, the water is going to get fed to the toilets and the galleys. Where we're coming in from the water supply, we're going to take a tapping cold water up to the taps. Yeah, and some of that water we're going to divert into a water heater. The water heater will take that water up to, I think it's 50 degrees. Yeah, so now we're feeding up hot water to the tap as well. We've got our sink, and in the bottom of the sink we've got the waste drain, and in the waste drain we've got the plug. The plug, and I think it says it in the notes, I'll come back to it if it doesn't, but the plug is normally held in the closed position so we don't lose cabin pressure. Yeah. Yeah, so your inlet, yeah, water up to the water heater, water up to the cold water tap. Anything else on it? So this area here is the waste bin that lives under the sink for your hand towels and what have you. The outflow from the drain, yeah, straight through and off to either a collector tank or atmosphere, and the overflow in the sink. Yeah, if we fill the sink too much, then we've got the overflow facility there. That is about it for the toilet supply, I think. Yeah, fed to the various toilets and galleys. Supply connected to a three-way valve, directs water to the hot and cold taps or the drain system. Typical water heater. Capacity will vary, but the figures stated in the notes, don't worry about it. 1.7 litres. Heater contains electrical elements inserted in the bottom of the tank. Heater switch will be on, yeah, and the cycling switch in the bottom of the heater keeps the temperature around about 50 degrees. If that heater fails or the regulator fails, yeah, and the water carries on heating, there is a secondary overheat switch that kicks in at 90 degrees and it'll switch off the heater. Yeah. If the heater's switched on, there's a little light there. Yeah, if the thing overheats, it'll switch the heater off at 90 degrees. The light will go off. Once the thing's cooled down, yeah, there's a little button on the top of the water heater, a little rubberized button. We can just press that. Pardon me, by pressing that, that's going to reset things. Yeah. Once the heater resets, if it has reset, the light will come on again and everything will run as was. So please make a note of those temperatures. Yeah, for your sink, for your hot water supply in the toilet, cycling switch keeps the temperature around about 50 degrees C. As a backup, yeah, as a safety switch, if that regular switch fails, yeah, the overheat switch will kick in and trip everything off at 90 degrees C. Once we've cooled down, we can reset by pressing the reset switch. It says normally covered with a little rubber grommet. Just podge that and away we go. If we've cooled down sufficiently, it'll let us run again. Yeah, there's a pressure relief valve fitted in the water heater. should we get excessive pressure due to overheating, if either of those switches fails, then the core plug will go. It'll drain water out, but obviously as the water's drained out, the temperature is going to drop, so protecting us. Badoom. Yeah, again, just a layout. Yeah, what comes in. Talks about filtering. I forgot to mention that with the water tank. The filter in there normally made out of paper. It's a low pressure system, so we don't need the high pressure filters. So there's normally a paper filter in the system, and I think it does mention that at the start, doesn't it? So drop your panel, yeah, filter in there, water. In the in the system, yeah, a little light. We've talked about that. The reset switch at the top. Heating element, 50 degrees C, 90 degree if the switch is gone. That's your plugs. Normally kept in the closed position to preserve cabin air. Yeah, the tap for the sink, we've got a hot water tap, cold water tap. The drain plug, yeah, press that, it opens the drain, all the water will google out, and away we go. Lots and lots of pictures. Yeah, your taps. Again, there's nothing we need to worry about on there. Yeah. From our notes, picture of the taps, the self-venting tap just means that any air that's trapped in the system is going to be bled out. The taps are referred to as faucets in America. Yeah, in the UK we call them taps. In America they call them faucets. So if anybody talks about the faucet, they're looking at the tap. Yeah, and again we've just got the hot water. Where's my little arrow? Yeah, we're going to have a hot water feed to one tap, cold water feed to the other one, and then a plunger that's going to be directed to the drain cap on the sink. Don't think there's anything else there we need to worry about. So the vent valve is there to prevent vapor locks occurring. Yeah. Opens the tap lines to atmosphere, so water will come out rather than air going in, so we're not going to get air locks in there. Has anybody got any questions on that? Dead easy, dead simple, dead straightforward. Yeah. And nothing again to worry about there. For the drainage system, the water drainage system, the wastewater, it says the collection and drainage systems vary. It depends on the aircraft type as to how we're going to get rid of the wastewater. Some it dumps overboard. Some aircraft it'll direct your waste back to a collector tank in the aircraft. Yeah, drain system, wastewater drain system connects the galley sinks, the toilet sinks, and the floor drains to the drain masts on the underside of the aircraft. Water waste exits the aeroplane via these drain masts in flight or on the ground. Wastewater drain system separate from the toilet system, and as I said, some aircraft the water will go back to the tanks. However, having said that, because it's the system that the notes concentrates on, we look at the overboard drain. Yeah, so what we're saying is that the toilets and the galley sinks and the floor drains are all interconnected. Yeah, so we'll have a sink in the toilets. Yeah, and from there's the outflow. That goes down to a common line, and then the sinks in the galleys. The little drain hole. Yeah, those galley sinks. Yeah, again, they're going to drain down into the common drain line. Entranceways and doorways, around the entranceways, doorways, and around the bottom of the galleys and the toilets, there are little gutters. Yeah, and the gutters are just small, I've just drawn that wrong, small channels, let me see, yeah, like small channels like that fit around the bottom of doorways and entrances and that sort of thing. And any moisture, any rain, any spillage comes in, will travel down these gutters, and again it will go out via a drain pipe too. So that's your guttering. Yeah, that will run out to the common drain line. The drain lines are going to be so angled and so positioned that any excess is going to go over to the drain mast, where it's going to be allowed to escape the aeroplane. And that is essentially what we're looking at. Very difficult drawing with a mouse. I hope you appreciate all the training I had to do to be able to do these Picasso-style illustrations for you guys. Yeah. If you have a look on page 11, yeah, as I was saying before, water basin drain plug normally kept closed when not in use to prevent loss of cabin pressure. Was your highlighter through that? And some aircraft wash basin waste enters the toilet waste tank. I said that, so you're aware of that. But certainly the drain plug closed position, watch for that one.
Which line could you please repeat again? Which line?
Yeah, it's on page 11.
Oh, yeah.
The wash basin drain plug normally kept closed when not in use to prevent the loss of cabin pressure.
Okay, got it. Thank you.
You got it?
Yeah, got it. Second last line, right?
Yeah. Just under where it says typical drain masts. Yeah, and the typical drains running from the toilets, the galley units, yeah, through the guttering, and all that wastewater being channeled back to the drain mast, and the drain mast on the belly of the aeroplane. And again, you can see the drain vents in the system too. Yeah, the wastewater drain, as it says, is designed to handle liquids only. But because the aircraft carries people, and people are inherently stupid, and it carries cabin crew, and cabin crew don't really care what goes down the sink. Sometimes, well, I say sometimes, it's not uncommon for solids to be flushed down the drain lines, and the drain lines get clogged and blocked. Yeah, so the design for liquids only. The tubing that we use, the drain lines, is fairly small diameter. We can use cabin pressure to help the flow of the liquids down to down to the drain mast. Yeah, and all it is just a little tapping of cabin pressure. Pardon me, just fed into the drain line, and all it's there is just to make sure that any waste is pushed down to the mast. Yeah, drain lines, obviously, because they're on outside the pressurized area or on a lower surface of the aircraft, drain lines could freeze. Yeah, so areas where those drain lines might be subject to freezing, they've got little heaters on them. Normally, it's a little piece of heating tape. Yeah, just a piece of sticky tape with an electrical element running through it, and that's turned on, and it just keeps the drain lines above freezing, so the liquids are going to flow. They're not going to clog everything up. So little heaters, and the drain mast itself. Once we get down there, that drain mast is heated as well. There's going to be a heater tape wrapped around there. So again, to prevent any freezing. Drainline blockage, occurs when solids it says accidentally placed in the drain system. It's just because, like I said, people just don't think. Yeah, don't get me started. I'm not very fond of the human race at the minute. So solids, what sort of solids are we going to get? Coffee grounds out of the coffee machines, tea leaves if they've been making pots of tea, bits of fruit debris, fruit pulp, where we've had a gin and tonic with a slice of lemon, that lemon gets dropped down, scrapings of other bits of food. And it says small items like toothpicks. And the one to watch for, right enough, is that when you go flying on a lot of aircraft, you get a little free gift which contains toothpaste, a little toothbrush, sometimes your socks and your mask. That toothpaste, it's only a tiny wee tube, and people take the lids off, put the lids on the sink side, and they get knocked off and they fall down the drain. Yeah, so that they can be quite damaging for the system. If we put milk and acids together, that's going to cause a sort of curdling. Your milk turns to a thick cottage cheese type affair, and again, if we get that can clog our lines up. Ice, if the heaters have failed for whatever, we can get ice forming. The drain system blockage prevention basically filters is there to stop any solids from entering the drains and straining out any deposits that may build up before they completely block things. So in the sinks, in the bottom of the plug hole, there's strainers, just bits of mesh. So as the cabin crew pour all the rubbish off the trays down the sink, the strainers should catch the bulk of that debris. Trouble is the strainers require cleaning, and nobody else but us is going to do it. What they should have is a waste chute, a waste disposal thing where they scrape any solids into that. But generally, a lot of stuff will go down into the drains where you end up cleaning it. When we're talking about heaters, the drain mast, I'm not sure whether it comes in later on, but the drain mast has got the heated tube fitted to it, and that heater there to prevent icing at the drain mast. If we didn't have that, there's a possibility of ice forming around the drain outlet. As that ice builds up, eventually it's going to get to the point where the ram air will crack it. The ice will break away from the mast, and it'll bounce along the bottom of the fuselage of the aircraft, and it can damage the structure. Or failing that, it drops from the air and crashes through somebody's roof. So precautions Yeah, prevent solids entering the system. Make sure that the cabin crew are aware. We don't need to worry about any of using tea and coffee, and that just means tea bags and coffee bags. Scrape everything into the waste bin and use the strainer. Prevent solids from forming. Yeah, small amount of water after we've put orange or milk or anything down. Yeah, just run the water. That should flush things through. And it says using hot or cold water. Yeah, just run that down the sink. Nothing there to worry about. Don't worry about cleaning it out. That's more for info. Water replenishment. Yeah, as we said about 300 times. We're going to get a cart, and that cart is going to have potable water in it. That cart is going to connect to the water service panel on the aircraft and top everything up. Yeah. Storage tank normally situated below the cabin floor, and as we said, it's going to be heated by either the conditioned air or there'll be a heater blanket around it. That tank filled from the water service panel. Water service panel we've already a look at, but there's a fill point. Yeah, there's a fill handle that we just operate to allow water in. There's also a drain point and a drain handle. Pull the drain handle, it'll open the tank, and the water will just come out of the drain port. That drain port will operate as an overflow as well. Yeah, pressure depends on the tank. Normally around 25 psi water pressure. Because it varies from aeroplane to aeroplane, that's not going to be a hard and fast rule. But if you remember, typically 25 psi for the replenishment for your water. Don't think we'll go far wrong there. Contents gauge, only if we're part filling, but as I said earlier, the tank's going to be filled till it overflows. We're going to go filter spill. Yeah, and then the contents, again, as it says, it'll be gallons or litres or whatever we want. Yeah, and there you go, little Joe Soap there, connecting his water line up. Yeah, operating the handle, and again, that water is just going to get chugged in. Once he's finished, he'll close off the fill valve, disconnect his line, and that's it. Yeah, every now and then we're going to have to disinfect the water system. Bacteria can build up if the water's not flowing regularly, if it's left for any reason. There's a possibility of getting bacteria in there, and that's going to make us poorly. So the water system does need to be disinfected at periods, as it says, when it's dictated to us in the maintenance manual. Yeah, once we've run the disinfectant through, we'll empty the system and then refill it. And the potable water that we're refilling with will have a bit of chlorine in it. Again, that's just to make sure that there's no bugs or anything. Yeah, if we put too much disinfectant in the system, it's going to contaminate the system, and it's going to make the water taste horrible. So it's pretty important that our disinfecting is done properly. Yeah, system, as well as putting chlorine in there, flushing it all through and then filling it up with chlorinated water, what we can do is disinfect using a solution of chlorine and vinegar. Yeah. So for a 30-gallon tank, yeah, 9 fluid ounces of chlorine, 9 fluid ounces of vinegar, and approximately 1 gallon of water. What we'll do is mix that lot together and then put it through the system. Yeah, flush it all through, and that disinfects everything for us. Unfortunately, I can't honestly remember whether that disinfectant solution comes up as a question. Yeah. Don't worry about the stabilized 2% and all that bollocks. But if you remember, 9 fluid ounces chlorine, 9 fluid ounces vinegar to every 1 gallon of water. Yeah. If you don't want to remember that, you're not going to lose anything really. Yeah. So what we do, we mix all the solution up, let it stand for 5 minutes just to make sure it's effective. Remove all your filters from the system. Yeah. Put the mixture into the water system and leave it there for an hour. Yeah. As it says, if we use too much, it's gonna make the water taste horrible. Once we've sterilized the system, then we can drain it all out and fill it back up with our potable water. Yeah. Chlorinated water, that's just telling us how we're going to get the chlorine in. Yeah. Don't worry about that. We just want to know that our potable water is normally slightly chlorinated, which is disinfecting it. Every so often, the whole system needs disinfecting. We can either flush it through with chlorinated water, or we can use that chlorine vinegar mix. Yeah. And once we've used the chlorine vinegar mix, washed it all around, drain all that out, and then just flush and fill the system with your standard potable water. Anything else I need to say there? I'm desperately trying to make sure that I've covered everything in the notes for you guys. We've covered every page, every aspect. The typical water system then. Water tank, yeah. Drain valve from the water tank should we want to empty it. And servicing panel that's going to let us fill the tank up. What else do we need? Yeah, tank normally under the floor. Fill valve, overflow valve. Then from the water tank, vary non-return valve. Yeah, we can go up to where we need the air compressor there running. Sorry, the air compressor putting a head of pressure on the tank for us. Pressure switch saves over pressurizing. Not a lot else we need to say there. Yeah, so what else we got? Yeah, from the system. Yeah, the drains. Yeah, drain straight out your drain masts. The bits that are coloured red there are heated. Heated, putting the water in and slightly warmed because it's near the service panel. Sorry, we need to just make sure that the pipework there is warm because that's adjacent to the skin of the aircraft. The drain mast is going to be heated. The drain outlines are going to be heated. Yeah. To prevent freezing, and there's nothing else on there I can see that we need to worry about, to even think about. Yeah, we don't even need to know the schematic. We just need to know that we're going to fill the system up, and that was our typical potable water. Has anybody got any questions on that?
In typical potable water system, can you explain landing gear squad switch?
Where does it mention squat switches?
The previous slide.
Yeah, we'll come at that though. The squat switch, yeah, is there for the heaters. For your drain mast, yeah, it's going to swap on the ground. That drain mast is going to be heated at, I think it's 28 volts. Yeah, in the air, it's going to trip over to a higher, just a different power supply. Yeah, so it's going to drain at the heater's going to run at 115 volts. That's all.
Jim.
Yeah.
Hello, Jim.
Hello.
In the in the schematic diagram.
This one.
This one. There is a red. There are red color in the tubes. You know.
Yeah.
And there is ground service panel.
Yeah.
So the ground service panels has two tubes. As on one is directly going to, water tank, and other water tank and then supply drain.
Yeah.
And other is directly going to water tank.
Yeah.
So I can you please explain this this red colored part?
What does that say?
Electrically heated.
Yeah, that's it. Yeah. All we're doing is putting a bit of heating on those lines to prevent the water that's in the pipes freezing, because it's out with the conditioning side of things. Those inlet pipes are going to get cold, and if there's any water in them, that water's going to freeze. So all they do is put a little bit of heater tape around them, yeah, just to keep them warm.
Okay.
Yeah. Runs from the aircraft system, yeah, 115 volts. The squat switch is for the drain mast, yeah, and all that's happening, the drain mast when we're on the ground gets a trickle feed to keep it warm, and then when it's in the air, the squat switches are going to kick it over to a different supply, again, just to keep it warm.
So a drain mast is a point from where those water are removed from aircraft. Or
yeah. Yeah, that's your drain mast. Yeah. So okay. All your sinks, toilet sinks, galley sinks, and the guttering that fits around the galleys and what have you, all run into an internal drain line, and the drain mast is just where the water is evicted from. It leaves the aircraft through there. Obviously, because this is sitting outside, if you're at altitude, that's got high potential of freezing. So we're just going to make sure that that's heated while the aircraft's in flight.
Okay, Jim. Okay, thank you, Jim.
Jim,
okay, no problem.
Jim, this squat switch is same as that wow switch?
Yes, it's exactly the same thing. Exactly the same thing.
Okay, Jim.
Yeah, on the back of the undercarriage leg, yeah, where your torque links, the squat switch is in there somewhere, and as the undercarriage leg hits the ground, yeah, it was the oleo shrinks, and your squat switch will make, yeah, the oleo is extended. The squat switch will be open. I think, I'm not 100% certain, but I think the term squat switch is American, and we just call them the wow switches, the weight on wheels switches, but they're exactly the same component. Okay with that? Do we want a 10-minute break there before toilets, or do you just want to push on to the finish?
Yeah.
what, 10-minute break?
We can
Yes.
continue if you want.
Okay then. We'll have 10 minutes and then we'll finish toilets. It won't take too long, and that'll give me a chance to go down and pay the window cleaner. So I'll see you in 10 minutes.
Sure.
Okay.
Sure, Jim.
Jimmy, what if I request for 15 minutes? I have little work to do.
Say that again.
What if I request for 15 minutes? I have little work to do. Can we start the class after 15 minutes? If you don't mind. I mean, if all my colleagues agree there.
It doesn't matter to me, but if everybody's back in 10, if you're a little bit late, you're going to miss absolutely nothing. So, so yes,
okay.
we can do it that way around.
Okay. Thank you, Jimmy. Anyway.
Okay.
खगेन्द्र
भन्नु न
के छ खोइ केही कुरा गरेको छैन हाम्रो टाइम फ्रेमको बारेमा
टाइम फ्रेम अब केही भएको छैन हैन तर टाइम फ्रेममा हामीले अब बुझ्नुपर्ने कुरा के छ भने घटायो भने फेरि यो अब यसरी पढाइरहेको फेरि कुद्छ होला नि त यो
अनि के गर्ने त Mr. Jim?
Yeah.
Are you on, man?
Sorry?
Did Sandeep say something about the time frame to you?
Yeah, he just asked if he could have an extra 5 minutes.
No, I mean the Mr. Sanjeev of NAT said anything about the time frame, reduction of the time frame about these classes?
The only time frame I've got is the one that we're running with, which is the. Just give me a second. This is the plan that I've got, and this is the only one that I'm working to. Yeah. So the 11, 12, 13 bit finished today. Yeah. We finished that this morning, and now we are starting the B1, B2 bit. Yeah. We're going to carry on with the B1, B2 bit till next Wednesday, the 27th. And then after that, it's just the B1s up till the 3rd of February. The 3rd of February, I am going to do revision of all the subjects for everybody. Yeah, and then on the 4th of February, it's the B1.1s, B1.3s, and the B2s all back together again. I rather think that is the electrics avionics, where it says 11C. Everybody does electrics, avionics, that stuff. And then we move on to the B1.3s, which is the helicopters. They're doing module 12. And after that, it's the B2s doing module 13. So that is the only timeline that I have. Is that okay? That answered your question?
Okay, I'll talk later about this.
Yeah, you can do, but that is what has been set up. That's what's being done. Excuse me, I've just got to go down and talk to somebody. It won't be a minute. Hi, have you got your purse with you? How's Lucy? I just need 40 quid from the cash point for the window cleaner. He's going to do the gutters tomorrow, and I owe him for 2 weeks, 2 lots of windies. All right then. If she doesn't mind lending me that, obviously I need cash to pay him with. I'll either transfer it to her bank or I'll give her it when I get a chance. All right, thanks very much. All right, see you later. Bye. Ugh. All right, just got to wait for one more, I think it is. Right, my favourite subject in the whole history of favourite subjects, toilets. Yeah, lovely thing to have to think about on a Monday afternoon, but an essential part of the aircraft. Yeah. Obviously, depending on the size of the aeroplane, depends how many lavatories, toilets that we're gonna provide for our passengers. So the number that we have on the aircraft is going to vary considerably depending on the size and what we're doing with the aeroplane. The normally accepted ratio, though, is around about one lavatory for every 50 passengers. Yeah. Yeah. one for every 50, but in if you go up into first class, they've virtually got one each, one for every 12. So the toilets, the lavatories that we're going to use is all dependent on the size and the usage of the aircraft. Obviously, more modern aircraft, the toilets are going to be quite Gucci, meet the criteria that we want. They're going to be lightweight. They're going to be economic. Yeah. So again, there's a little screed in there about the toilets on modern aircraft, very expensive, and include features that required a lot of investment by the airlines. They're all carrying on, pardon me, investigating ways to improve the design, improve the function, and more importantly, reduce cost. Yeah, we've got to maintain hygiene, safety, all the rest of it. So you find that most modern aircraft, rather than having the flushing type toilets, use vacuum flush. So rather than introducing liquids into the system that have got potential for corrosion, spillage, all the rest of it, what we use is vacuum technology, where the flush button, we punch the button, we get a differential pressure causing suction, and all the excrement in the loo is sucked back to a collective tank. At the same time, they reckon they're less smelly, those sorts of toilets. A lot lighter because we haven't got half the components that you need for the other stuff, and we're not carrying so much water because we don't need to flush with a liquid, so we don't have to carry that liquid. So we're reducing the weight that the aircraft's got to carry. Your basic toilets are modular now in design, so that everything is in a cubicle, and when we come to carry out maintenance on the aircraft, the whole cubicle's removed rather than individual components. We'll only take individual bits out if we have to repair them. Yeah, generally for servicing, the whole module will come out. A couple of plugs in the top and the bottom for your water feed, your electric feed, and away we go. Within there as well, we're going to provide remember we had the passenger service unit, the PSU, where we have an LSU as well. So if we get any major problems while somebody's sitting on the toilet, then the oxygen mask will fall to them as well. So save their life. The history of the toilets on the aircraft, yeah, again, depending on the size of the aircraft, how far we're going, we go from the very, very simple, yeah, right up to the Gucci stuff we see now. Yeah, the first type of toilet that they carried on the aircraft was just a little cup and a bag at the end of it. Yeah, that sort of went up the way to a plastic bottle. A bit like you get in a hospital, and there's an adapter on there for the females, which is very thoughtful. Yeah. Again, the simple basic toilet, yeah, is just a tube. Yeah, you pee down the tube, and that goes off to an overboard drain. Yeah, very, very old-fashioned. Not what we're wanting in this day and age. So as things moved on, yeah, we went to a more advanced basic, if you like. And the more advanced basic is what they call the Elson toilet, and the Elson toilet is just a bin, yeah, a bin that's got disinfectant in it and a bit of deodorant. Yeah, we put that bin, that bucket, into a little compartment. Yeah, put a seat on it, and put a lid on it as well, and that's us. That is your basic toilet. Yeah, just a little bucket we can pee into, we can poo into. And once the aircraft has landed, we take that out and dispose of the waste accordingly. Yeah, check it out, empty it, refill it with disinfectant, put the deodorant in, and stick it back into the aircraft. Very, very simple. Held in position by pit pins. Yeah, just a couple of locking pins on the floor. Bolt the toilet into position, and away we go. Don't even worry about connecting anything. Yeah, and stick a curtain around just for a bit of privacy for anybody that needs it. Yeah, big problem with these things. Yeah, as it says there, corrosion. Yeah, so doesn't matter whether you're a man or a woman, the chances of missing is quite good, and any urine on the floor, acidic, it's going to start eating into the aircraft structure. So these things aren't fantastic. Not fantastic. Yeah, slightly posher version. We'll put an armrest in now, put a little bit more of a comfortable seat on, but the same principle applies. It is a bucket underneath the seat. Yeah. We've got the removable tank. Yeah. Filler cap. Yeah, for putting our deodorant, disinfectant in. With this one, it's got a little flush line, so we can clean the thing out, flush it through. Not a lot else to say there, quite frankly. Just a basic toilet. Held into place, yeah, pit pins. That's a posher version. So we sort of moved up a bit, and we came up with liquid flush toilets. Yeah, and liquid flush toilets, you still find them kicking around, even though they are. I was going to say going out of fashion, but as aircraft are replaced, yeah, the vacuum toilets are becoming more and more common. The liquid flush toilet, yeah, each one is a completely self-contained, and its waste collection tank mounted directly below the toilet bowl. Yeah, each toilet unit has got a seat, a cover, nice surround, make it look a bit more acceptable. The toilet bowl, yeah, as it says there, a tank top and a flushing mechanism and a waste tank outlet. So let's see if we can plod through this. Yeah, typical toilet. Yeah, we've got the toilet bowl. On top of that, there'll be a seat. There's a motor pump, and that pump runs a filter. I'll come on to that in a minute. There's a vent for the tank, yeah, a drain line for the tank, and we can plug in and we can flush the tank out. So any crap that's accumulated in there, we're going to empty it out the drain, and then we're going to connect a water supply with disinfectant, and we're going to flush the thing round. Yeah. So what we got? Yeah, we've got a toilet. Yeah, we've got this little tank underneath it. Yeah, the tank, it's got its own little flushing unit on it. Yeah, it collects waste material in the waste tank. The waste tank, we disinfect, deodorize, and dye the liquids that have come from the person. We can separate those from the waste, yeah, by filtering, and we can use that liquid again. How's it going to work? Oh, Struth. Yep. what we're going to do is flush the toilet by pushing the flush button. Yeah, that pushing the flush button energizes an electrical timer. Timer completes a circuit and energizes a motor, which drives a pump and a self-cleaning filter. Right, one for your highlighter there, page 21. There are 3 types of rotating filter or self-cleaning filter that we might get. You can have a fixed mesh type, a rotating mesh type, or a rotating disc pack. Yeah. So there's my little pump. Yeah, there's my little pump. Let's do it off here. I press the flush mechanism. The motor starts running. The motor starts running. It rotates this this disc, this filter assembly. Yeah. As it's running, it's pulling liquid through a filter, and as it's filtered, it's going up through the pump to the nozzle ring, which is around the bowl of the toilet. That water comes out and it flushes down all the waste, and that waste dribbles down into the waste tank. So you've got your waste sitting in the tank. Yeah. The next time I press the motor, any solids that are in here are chopped up and separated from the liquid by the filter. Yeah. Again, that liquid, yeah, squirts down and cleans out any solids. Aircraft lands. Yeah, I need to empty the toilet. I go to the toilet servicing panel. Yeah, here there's a drain valve, and I connect the drain line up, pull a drain handle, that pulls the plug out the bottom of the tank, and all this blue, disinfected, contaminated water runs down the drain line into the collector truck outside. Once I've done that, I can connect a flushing line up, and that flushing line just sprays water around the top of the tank, water and disinfectant. That flushes it through, and it comes out the drain line as well. Once I've flushed it all through, I'll close off the drain valve, fill the tank up to the required level, and that's the tank reset, ready for the next flight. So toilet flushing initiated by pushing the button, energizes the timer. Timer completes a circuit to energize a motor, drives the pump, drives the filter. Pump draws liquid through the filter, pumps it through a toilet bowl flush ring, cleans the bowl out. End of the cycle, timer opens the circuit, rearms itself for the next circuit cycle. Next operation, yeah, again, make a note of that. The motor will run in one direction the first operation, it'll run in the opposite direction the next operation, and that prevents the filter from getting clogged up, from becoming choked with waste. Yeah. Toilet bowl normally made of stainless steel, low part of the bowl closed by a hinge separator, very lightly sprung loaded to the closed position, which is basically a wee flap. Yeah, so in the bottom of the bowl there's a wee flap there. All your stuff sits on the flap, push the button, flap opens, yeah, flush line runs, everything down into the collector tank, and resets for the next journey. The pump itself, reversible 3-phase 115 motor, 115 volt motor fitted on top of the waste tank. Motor drives the filter, and an impeller used to pump the flushing fluid up to the top of the toilet. That was my flush line. It's just the other picture, but not coloured in. Basically, this is your filter. The filter either a mesh or a series of discs. Yeah, and all they're doing is rotating against a sort of knife edge, and that chops up everything into minute pieces so it doesn't clog the system up. Anything that's caught on the filter, because it runs in the opposite direction next time, it'll get scraped off. The impeller is there to draw fluid through the filter, and it draws that fluid up through the filter and sends it on up to the toilet flush line. The motor just driving the gears that will go backwards and forwards. Yeah, your impeller in there, pulling the fluid up through the flush line to the flush ring in the toilet. Nothing else I need to say there. Different types of filter. The disc type, stack of flat wheel, flat shaped discs. Each disc separated by a spacer. Thickness of the spacer holds the discs apart. And depending on how far apart the discs are, depends on how much filtration we get. Stationary knife blade mounted beside the disc stack. The blade enters into the slots created by the spacers. Filter rotates. All the waste is combed through the slots by the cleaner blades, and that breaks down all your waste. Gotta hate these. Basically, you've got a series of little discs, and the discs are held apart by spacers. I'll just do 3 because it's easier. Yeah. So you've got those little discs, and adjacent to the little discs, there's a stationary knife edge. Yeah. As the discs rotate, this knife edge is cleaning out the gaps between them. How much the filter strains depends on how big these spacers are. The closer they are, the discs together, the more filtration you're getting. But if the closer they are, we've got to make sure that the cleaner knife is of a suitable size. Your rotating mesh filter, similar sort of thing. There's a wire mesh that may be fixed or rotating. The rotating filter has a mesh basket surrounding the pump inlet. Yeah, and that prevents any solid waste entering. Yeah, so you got your mesh basket. Yeah, you get the idea, I'm sure. Yeah, and next to the mesh, there's a knife edge. Yeah, so as this mesh basket is rotating, anything that's caught on the mesh basket is going to get scraped off by the knife edge. Yeah, the mesh filter is going to prevent any solids or anything like that from entering the pump mechanism. Motor runs, yeah, one way, then the other way, just to make sure that the thing doesn't clog. Note from page 23, electric toilet motors must be fitted with a thermal protection device, a fuse or a circuit breaker to prevent them overheating. Yeah, that was the cause of an aircraft loss years and years ago. The toilet pump jammed, and as it was trying to run, it was overheating, and eventually it caught fire. So one of the regulations now is that they've got to have a fuse, a circuit breaker fitted in the system. Drain valve from the tank, yeah, just operated by a control cable from a panel out on the external surface, and as we pull the control cable, it pulls the plunger up, and all your waste is going to evacuate to the tank. flush line, perforated tube, yeah, just allows the liquids through. And again, with the typical system, I don't really need to worry about the circuit diagram. None of that is for any concern during the exam. Just the various components that are in there. As it said, there's a little tapping via a venturi, so cabin air through the venturi is causing any odours that are in the area to be pulled out and dumped off overboard. We kind of saw that in our ventilation the other day when we were looking at ventilation. Everybody okay with that? Compressed air toilet, yeah. Compressed air just avoids the use of the electric motor. Some aircraft use compressed air to operate the flush mechanism. Can't say I've ever come across it myself. But got a reservoir of air. Yeah, that reservoir of air. We push the flush lever. That reservoir of air will allow air to come down. That air now pushing up fluid up the pipe up to the flush ring, yeah, where it's all going to drain down again. And away we go. We're back into the same cycle. So we're just using the compressed air rather than an electric motor. Again, we don't need to worry about that at all. The big one nowadays is the vacuum toilet. Yeah, with your liquid flush toilets, there is, because we've got liquid, it's going to create corrosion or put the risk of potential corrosion in the aircraft. And they take a long time to drain and flush and replenish. So you've got a time penalty when the aircraft's on the ground. So one of the ways around that we've come up with is what they call dry toilets or vacuum toilets. Yeah, and those toilets are all connected to a centralized storage tank somewhere in the belly of the aircraft. So your waste tank, yeah, toilet up at the front here, pipeline back to the waste tank. There could be a toilet mid-aircraft. There could be one at the aft of the aircraft. Yeah, but we'll have a look at the operation of these things then. So your toilet connected all to a waste tank. Wonderfuel. Yeah, toilet uses what they call an evacuated waste container. So that tank, yeah, is empty. And what happens is we bring that tank down to a lower pressure than that of the aircraft. So when we press the flush button, we get a pressure differential, and that pressure differential causes the stuff in the toilet to go whizzing along the pipes back to the tank. So that waste tank is evacuated to, I can't remember the exact figures, but let's say 2 psi. In the toilet cabin, we're going to be pressurized to, let's just say 8 psi. So now you've got a differential. So as soon as you activate the toilet, yeah, that pressure differential wants to even out. So everything gets sucked along the pipeline back to the waste tank. Yeah. The vacuum generator there to ensure that the tank is at a lower pressure, yeah. And we've got an air outlet there just to make sure that the odours and everything are vented out, yeah, so we don't get a build-up of nasties. Right, where am I going from here? Yeah. Is that an old picture? Have a look. Yeah, vacuum toilet uses evacuated waste container, toilet bowl flushed, valve opens, waste sucked along the pipe into storage tank. Clean water from the clean water drinking tank is used to rinse the bowl, and once that rinse has occurred, that water again is going to get taken along to the waste tank. Large aircraft, more than one tank, maybe 2 waste tanks. Some of the toilets use one, the remaining tanks use the other, so we're not relying on one tank all the time. By sharing the load ensures if one tank's full or fails for whatever reason, we've still got functioning toilets on the aircraft. If we do get that, there's a warning light on the cabin attendants panel just to say that this toilet is out of action. Yeah, aircraft flying at altitude, differential pressure, I've already been through that. Differential pressure evacuates the air from the waste tanks. That page number 28, yeah, just above vacuum toilet operation. When the aircraft is flying below 16,000 feet or on the ground, electrically driven blowers are used to pump the air out of the storage tank to create the vacuum. So when we're airborne, above 16,000 feet, we've got a natural pressure differential. So the tank is going to be a much lower pressure than the cabin. So if we open the cabin up, open the toilet up, that pressure differential is going to create the suction to pull everything out. If we're below 16,000 feet, we haven't got that sufficient pressure differential, so we're going to put a pump in there. That little, it says a electrically driven blower. Yeah, it's just a little vacuum pump that's going to pull the air out of the tank, and away we go. And that is what you get, your toilet assembly bolted in, yeah, your bowl, discharge pipe, yeah, so as the pressure differential kicks in, all your waste is going to go down that way, and then there's a rinse water that's going to operate and just rinse everything out at the same time. So yeah, let's see if I've got that slide. Yeah, that's your vacuum toilet. This one, toilet removed and everything on test. Yeah, and we can see the water pressure, the vacuum pressure, and we can operate this thing and do our functional checks on it. Have I got the same picture as you? That's what I'm trying to look for. Right. The operation of these things, I'll just run it through off the notes. Yeah. Press the flush button, cycle starts. If the aircraft below 16,000 feet, the vacuum blowers are switched on and they will evacuate the tank to create that pressure differential. 1 second after that, a water valve is opened and pumps water to the rinse ring. Yeah, so from your potable water, supply around to the rinse ring. Flush valve opens for 4 seconds to allow the waste to be sucked away. So as you press the handle, vacuum blower evacuates the tank. Water valve opens. Yeah, water valve allows the flush ring to operate, and at the same time the flush flap opens. Flush flap opens and allows the waste to be pulled off down to the waste tank. Yeah, the timer, yeah, makes sure that everything is switched off and allows everything to reset, so it's all ready for the next cycle. Yeah, so flush and handle, yeah, vacuum blower that runs, depressurize the tank, water valve opened, yeah, sprays water on the top edge, flush valve opens, and away your stuff goes. And then there's the delay mechanism just to make sure that everything is ready for the next flush. So again, your toilets, your potable water supply, yeah, podge the button, swish, 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 yeah, weak, and off to the waste tank. The vacuum generator there for below 16,000 feet, yeah, and your differential pressure line will make sure that tank is evacuated when we're above 16,000 feet. Anybody got any problems there? Nothing that I need to say there. Each toilet system has its own service panel. Service panels on the lower surface of the aircraft, and it's from these points that we drain and we flush the system out. So for each lavatory, yeah, we've got its own drain line. We've got its own flush line because we need to flush the system through. Drain handle and the waste line, right? Yeah. The aircraft storage tank is going to be emptied into what they call the honey truck. It is just a big truck that comes along and sucks all the shit out and takes it to a disposal area. If you go on YouTube and Google or YouTube aircraft toilets, there's a cracking little video of a man works at, I think it's Frankfurt Airport, and his job is to drive the collection vehicle and empty it. And I've never seen a man so happy in his work on a film. He loves it. Yeah. So he goes along, yeah, and he connects up to the waste drain, makes sure that everything is ready, yeah, and then opens the drain for whichever toilet it is he's wanting to empty. Once that drain's emptied, the effluent falls down the drain line, it gets sucked into the big collector tank. Once he's done that, he'll connect his truck up to a disinfectant supply, and that just flushes everything through. Where else are we going? Yeah, if we're using a waste line with a rubber bung in it, that waste line rubber bung must be withdrawn using a Y coupling. And the reason for that is it's going to save you and everywhere else getting covered in crap when we open the drain line. Yeah. The rubber bung fits in the drain line. Yeah, and within there's a little female thread. Yeah, we connect the Y coupling up. We screw the handle into the rubber bung. Make sure everything's connected properly. Make sure it's all ready. Pull the handle back, and that withdraws the bung, and that allows everything to come out of the tank down to the collection point. Yeah. So that's your sort of thing there. Your drain valve from your tank. Yeah, the little bung in there. Put the Y connector on. Yeah, screw the handle into the rubber bung. Pull it back, and now all your effluent can go off into the drain line, off to wherever it needs to be. Yeah, don't need to say any more than that. Toilet waste tank rinsed via the rinse line that I just showed you. Drain it out again once all that flushing has been done. Drain it all up, and then replace the rubber bung in the drain pipe. We can put a small amount of water and disinfectant back into the waste tank. Please note, bottom of page 31, after the toilet drain coupling is removed, that Y connector. A leak check is carried out around the toilet drain outlet. That's to ensure that there's no leakage there. If we had leakage, that would form ice around the drain point. That ice breaking away would damage the aircraft as it got carried along by the airflow. So just make a note of that if you would. Yeah, page 31 in the note. After the toilet drain coupling is removed, a leak check is carried out on the toilet drain outlet. Yeah, your big Y coupling, yeah, large aircraft, you're going to connect that up properly, then you're going to withdraw the bung. I'm sure you can imagine if you didn't have that connected properly, yeah, if you hadn't made sure all your connections were tight, you pull that bung out, where's all that crap going to go? All over you. Yeah, so make sure you connect everything up properly, save yourself an awful lot of pain and an awful lot of embarrassment. Yeah, the honey truck here is where the all the effluent is going to get drained back to. Flushing line, yeah, so we can flush everything through. And again, once we've flushed it all through, push the drain bung back in. Yeah, disconnect everything, and then a leak check. The leak check will be done in accordance with the maintenance manual. Yeah, and again, your little man. And as I say, if you have a look on YouTube, the man at Frankfurt, I think it is, he gets really excited about it all. Yeah, obviously your drain line as well. Yeah, your drain from the tank, we'll open that. Any water spilled on the toilet floor goes through that little gutter that we mentioned before, and that goes into the waste tank drain line too. So that is taken back. The toilet waste drain fitting is electrically heated to prevent the freezing of any liquid that might be in the drain line. Yeah, so anything that comes past the drain valve in the drain line, that drain is electrically heated. That's just a picture of your service panel. Yeah. That is, again, just reiterating the fact that you need to wear the correct PPE. If you don't, it's really going to ruin your day. Chemicals used, yeah, make sure that we mop up any spillages, make sure that all the tools that you use have been wiped down, and again, wash your hands before eating or smoking or anything like that. Yeah. The last thing you want is crap on your hands. Compartments themselves, as I said before, the compartments are made up as modules. And because the modules, we can easily remove them from the aircraft and refit them once we've serviced them. Normally made from fiberglass walls, decorative, all the rest of it. Yeah. Talks about toilet equipment. I wouldn't worry about that. The stuff that we're going to put in the toilet, yeah, mirror, coat hook, razor socket. It says ashtray. I don't think there's any aircraft now where we smoke. Dispenser equipment is just your towels, toilet paper, soap, all that sort of thing. And the disposal equipment is basically anything that we need for getting rid of stuff, sick bags, razor blades, that little lot. Don't worry about the equipment that we're going to keep in there. That's all common sense stuff. But the module contains all of that equipment. It's illuminated by lights located on the ceiling. So whenever aircraft powers on, yeah, the light is going to be operating. But the light works on a dimmer switch. So when the door's opened, the lights will come on bright. When the door's closed and locked, if the door's closed and we're unlocked, the lights will dim down. It just saves electrics, really. Yeah. Toilets in a group, yeah, if we've got multiple toilets, they're connected into a common toilets occupied light. So when you look down through the cabin, if you see the little light on, yeah, the toilets have got people in. If the light's off, one of them in that group is unoccupied. Anything else I need to say there? No. Toilets, yeah, we can open and close them from either side. So if you get a child locks the door and can't undo it, we could unlock the door. In an emergency, if somebody has a heart attack or whatever, again we can open the door. Toilets fitted with smoke alarms because we don't want people smoking in them anymore. And the smoke alarms will give a warning signal if smoke is detected. The ventilation system, we talked about that before, yeah, from the galleys and the toilets. All we're going to do is draw out the air there, and by drawing that air out, we're taking away all the foul odours and the foul smells. We're making sure that there's a constant supply of air there. That air goes through a muffler, and the muffler is just there to damp out the sound of the air rushing through the pipes. Through an NRV, so it's only going to go one way, and then it comes up as a venturi. Yeah, and the venturi is there to make sure that we don't lose cabin pressure as the air from the toilets and the galleys area is being evacuated. And again, straight from the notes, yeah, galleys toilets ventilated by allowing pressurized air to escape to atmosphere. Galleys are ventilated through vent inlets in the ceiling panel. Toilets vented by air flowing through a gap between the toilet shroud and the toilet bowl. Yeah, and then there's behind the toilet shroud there's a vent duct. So all we're doing is allowing free air to circulate around and dumping it overboard in a controlled manner. The different components, well, we saw these in our cabin conditioning. Yeah, we saw them in the structures, I think it was. So you should know these, that the venturi limits the outflow of cabin air when the aircraft's pressurized. The check valve just carries everything in one direction. The muffler is, as the name suggests, it just deadens any noise in the pipework. The vent inlet, yeah, allows the air through to take away those odors. And the restrictors are just there to make sure that there's an even flow of air between the galley and the toilets. Yeah, we'll put restrictors in the system just to make sure that everything is evened out. Anybody got any questions on any of that? Sound. Right, fire. Worth remembering, page 36, that CAP 747 requires all toilet waste containers provided for flammable materials must be inspected at intervals not exceeding 72 hours. Yeah, and that inspection ensures that any doors, flaps, latches, seals all operate correctly. So within our toilet compartment, yeah, we've got the waste container, sprung loaded doors on the waste container, likewise up there. So we put the stuff in. Yeah. There is potential if somebody drops a cigarette end in or whatever it might be, there's potential for fire. So CAP 747 saying that we've got to check those intervals not exceeding 72 hours. Yeah. If we find any defects on any of the stuff we inspect, that's got to be corrected. The bins themselves, the containers, are made from fire-resistant material. They will contain any fires in there, but in the unlikely event, we need to carry out these checks to see if anything has happened. Smoking not permitted in the toilets, so no smoking placards should be provided inside and outside. It talks about ashtrays in the notes, but there are very, very few aircraft now on which you're allowed to, on board, you're allowed to smoke. Typical toilet. Yeah. And your fire extinguisher. Yeah, we'll come on to that in just a moment. Cap 393 says that each toilet compartment must have a smoke detector fitted. Smoke detector operates a warning light and or an audible warning in the passenger cabin. It may also operate a warning light on the flight deck. Normally, it's going to be like the ones you've got at home, whereas if smoke's detected, it's going to make an awful racket. Yeah, so we can hear that the smoke detector's gone off. Minimum number of handheld extinguishers in the passenger cabin. Yeah, and those extinguishers, it says a minimum number must be Halon 1211. Yes, some extinguishers, they might use CO2. Yeah, again, it depends on the size of the aircraft, but we're going to put a minimum number of handheld extinguishers in the passenger cabin. As we saw this morning, depends on the number of passengers that we're carrying. And the percentage of those extinguishers are to be Halon 1211. Well, having said that, with the way fire extinguishers are going, yeah, we're wondering. Yeah. Your Halon extinguishers, yeah, it says red and chrome. Yeah, it tells you what you'll have in it. Your handheld extinguisher, as we saw this morning, we've just got an operating handle. The operating handle held in place by a safety catch or a safety tie. That safety catch, that safety tie isn't going to prevent operation of the extinguisher. It's just there to prevent inadvertent operation. The contents indicated by a pressure gauge, and so long as that gauge is reading in the green sector, we can be fairly confident that the extinguisher is going to operate when we want it to. Held in by a quick release strap. So in the event that we need to get hold of the extinguisher, we just flick the strap and it will release. We don't want any arsing about. Again, the one on the board, yeah, all we've got there is a little safety catch. We'll flick that, yeah, press the trigger, and the extinguisher will be discharged. Yeah, little label to tell us when it was last serviced to make sure that it's in date. Yeah, and the pin just going through the back of the handle, so we just whip that pin out, flick the safety catch, press the trigger, and the extinguisher should do what it's meant to do. Yeah. Within the toilets, we're going to have built-in fire extinguishers, automatic fire extinguishers, and they are just little bottles containing a pressurized extinguishant, and the outlet pipes are sealed with a fusible plug. Yeah, that plug, that tip, it's just made out of like a posh solder. Once the temperature reaches a certain point, the figure quoted in the notes there, about 175 degrees Fahrenheit, that tip will melt and it will cause the extinguishant to discharge. So they're normally contained in the waste bins and what have you in the toilets. On the outside, or sometimes on the inside, we'll have the temperature tape. And again, that will change colour to indicate whether we've had an overheat in the toilets, whether there's been a fire in there or not. Yeah, in 393, your smoke detector. That's what we're looking at there this morning. Yeah, smoke detector in there, just telling us if it detects smoke, it's just gonna give us off an audible warning. As it says, that there might be a repeater in the flight deck, there might not, just depends. That's your fusible tip extinguishers. Do I need to say anything else there? Temperature indicator strip. Recommended that fire access points be built into the waste containers. We don't need to worry about that. That's examples of your extinguishers with these little meltable, fusible tips on them. Yeah, and we just mount them in the various containers. If we get a temperature rise above a certain point, this little tip will melt and the pressurized extinguishant will be released into the compartment that the extinguisher's fitted in. Yeah, they come in all sorts of shapes and sizes, but that's our water and waste and toilets in the aircraft. Has anybody got any questions on any of that little lot?
Hello, Jim.
Hello.
Can you please again explain this gallery and toilet ventilation system?
The ventilation system?
Yes.
Yeah. Around the galley.
Okay. Okay.
Yeah, where you can do all your cooking. And around the toilets, there's going to be quite a lot of foul smell. So what we want to do is to take that contaminated air away. And we do that by ventilation. So in the galley, yeah, we're going to run little fans up to ducting, yeah, in the roof of the galley. The air will be drawn up into the ducting. Around the back of the toilet bowl, the same sort of thing's happening. We're going to put vents in there, so the air that's circulating is going to be attracted into the vent line, the toilet ventilation line. Yeah, you might find that there's a little fan built into the line. It doesn't show it on here, but that's just making sure that the contaminated, I'll call it contaminated air, is being pulled up into the vent lines. So the toilets, the galleys, yeah, as the air's circulating, yeah, it's being drawn into the vent line, and then it's going to go through a silencer. They're calling it a muffler on here, a muffler silencer. It's the same thing. And what that muffler's doing is just damping out the sound of the air running through the pipes, a bit like we had the other day when we saw the silencer. Yeah. The air going through the muffler, through a non-return valve, just to make sure that air is flowing in one direction only, and it's going to be pulled out of the aircraft via a little venturi. The venturi is there to make sure that we don't lose cabin pressure, yeah, because this thing's open all the time. That venturi is causing a restriction, yeah, and because it's causing a restriction, it's making sure that we're not allowing cabin pressurization to be lost.
So, Jim, there should be one fan to withdraw those air.
So sometimes,
one
not
fan,
always,
which is not shown in the diagram.
Sorry?
There should be one fan or some pump which can draw those air through muffler and NRV and exhaust those air.
So sometimes,
out of
but it's not necessary because the air is continually circulating. Yeah, don't forget that the cabin air is constantly being pushed in by the engines. Yeah, so just the fact that the air is pressurized will allow the air to go.
The cabin air is. So cabin air is pressurized. This galley and this toilet air are pressurized, and then as the aircraft is flying, the outside air is low pressurized. So only because of that differential, these are getting exhausted. So that is what I understood, Jim.
No, not really. Forget about the fan. Yeah, some large aircraft might have a fan in the line, but forget about that. What I'm saying is, in the aircraft, yeah, that was handy. The engines are running, and I don't know why it's doing that. We're getting we're getting pressurization air being pushed into the cabin. Yeah, that pressurized air, we need to allow it to escape somewhere, don't we? So some of that pressurized air, yeah, is going to go up into the vent line. Yeah, so that the air that's around the galley and the toilet areas is just going to get drawn up into the vent line, where it's going to get ducted overboard. The vents around the roof of the galley, yeah, we've just got lots of little vent slots where the air can escape. Around the toilet bowl, at the back of the toilet bowl, again, there's louvers around there, so that the circulating air will get drawn up into the vent line. Once it's up in the vent line, yeah, it's going to get directed through the silencer, through the non-return valve, and out to atmosphere. The prime purpose of the venturi is to preserve cabin pressure. Yeah, so we're pressurizing the cabin, we're pumping pressure in there. We don't want that to escape. We need that to stay alive. We need to keep the cabin pressure at a certain level. Yeah.
Okay, Jim. Got it. I got it.
Okay.
Thank you, Jim.
That's quite all right. Anybody else got any questions at all? Right, well, if nobody's got any questions, there's a bonus. That's it for today. I told you water and waste was a nice, simple, easy subject. Tomorrow we will have a look at pressurization and oxygen systems. The two of them walk hand in hand. Again, there's not a hideous amount to them, but we'll take a walk through pressurization and oxygen. So if you haven't got any questions, if you're happy with everything, I'll say thank you very much and see you tomorrow. If you have got any questions, I'll stay online for a few minutes so you can ask anything that you need to.